6:30. 6:30 we'll have.
Maybe 6:30?
6:30 the certificate distribution we'll be having. So.
We have presentations tomorrow, no?
Ma'am, here it is.
मैम और हमें पार्टिसिपेंट से फीडबैक फॉर्म भी भरवाने थे
हाँ वही
और सर से भी फिर कराना है ये सारे आप अनाउंसमेंट्स में पकड़
हाँ बहुत काम है बट लेट मी इसे शुरू हो गया क्या नहीं यूट्यूब शुरू हो गया ओके गुड मॉर्निंग वेलकम टू दिस एक्साइटिंग थर्ड सेशन ऑफ ज्ञान टुडे इज गोइंग टू बी a very exciting day because we are covering two applications on climate change preferences from India and couple of more, and we have also built in hands-on assignments for today. So we'll actually show how data codes work, and we'll also give you data set to try your own and how to work on it. So I believe that it's a long day, but an exciting day with a lot of stuff to cover today.
We already have the data sets on.
They already have the data sets, so I think in the post-lunch session, we'll ask them to run. Okay. The title of this course had climate change preferences, and the two of the papers and the applications of discrete choice experiments that we are going to cover in the first half of the session, they are both on climate change measures and their applications from India, so we can all relate very well to them. Okay. So when we talk about climate change, there are two broad policy measures. One of them is climate change mitigation measures, and the other one is adaptation measures. Mitigation measures are measures which we take to mitigate greenhouse gas emissions. How can we reduce greenhouse gas emissions? And those kind of policy measures, they come under mitigation. But we also know that, despite all our efforts, climate change is happening and lots of extreme events are happening. That means that at the same time, we should also be prepared to adapt to whatever changes are brought about by climate change. And these measures are called adaptation measures. So, one of the applications that we are going to cover today is on adaptation measure, and the another one is on mitigation measure. So, the first, paper that we are covering today is about farmers, and do farmers value rice variety tolerant to droughts and floods, and there is evidence from India. So that's the first application of discrete choice methods that we did. We did this application in India, and it's one of the adaptive measures, and I'll talk about it. How is this an adaptive measure? Just to slides.
Not fixed. Give me my fix it.
Okay. This paper. Next कर दो.
Next.
नहीं अभी इससे कर दो.
Yeah. Just go on. Yeah.
So this work is joint work with one of my former PhD students, Anchal Arora. She's now faculty at Indian Institute of Foreign Trade, and with Patrick Ward. Patrick Ward is now faculty at University of Florida, USA, and this project was funded by International Food Policy Research Institute. So what are we interested in, learning here, and what is this project and paper about? What does climate change do? For Indian subcontinent and South Asia, one of the impacts of climate change is to change monsoon patterns. It can delay onset of monsoon, monsoons can recede earlier than that. There can be extreme rainfalls in certain times. So this rainfall pattern changes due to climate change. And we know that how much farmers are dependent upon rainfall. Especially in India, like over 68% of the farmers, they don't have irrigation facilities and they are dependent upon rainfall. If there is a change in rainfall pattern, that's likely to affect their productivity, yields, crops may just die, and therefore we need to think about, can there be any adaptive measures that farmers can take to protect themselves from this variability in rainfall. So that's what we're trying to find out in this paper. And the experiment we do it is with rice crop. Rice is one of the staple crops. All the population or majority of the population in India depends upon rice as food for alleviating hunger or to meet our food requirements. And this rainfall variability, water stress, this is another name for it, that affects rice productivity, and if productivity is low, then that affects farmers' income, their livelihood, employment opportunities, poverty. So we can see that so much of development is related to how farmers are able to cope up with the water stress that might happen due to climate change. And this variation in monsoon can result in droughts. So if there's no rainfall or delayed rainfall, there can be a situation of droughts. But we also see there are flash floods. So and Odisha is one of the states that suffers from both droughts as well as floods. So if there's too much rainfall, water is locked and your crops can be destroyed. Okay. So climate change is likely to increase frequency of these extreme weather events, and therefore we want to just study that what can be done about it. What kind of adaptive measures can be adopted and how to protect farmers. So one of the adaptive strategy that I'm interested in here was that if there are some new seed varieties which we are calling as stress tolerant, which can tolerate this kind of a water stress. So some seed varieties can tolerate droughts and some seed varieties can tolerate floods, or just to explain it better, submergence. What happens is that when there are floods, the crop gets submerged in water for a longer period of time. And a normal crop will die because if it's in water for 10 days, it'll die. But there are some new seed varieties which are called submergence tolerant varieties. They can tolerate submergence for more number of days. It's not like infinite number of days, for months, no. So maybe up to 15 days or 20 days. And these varieties are at a development stage. So a lot of investment goes in, international money goes in, billions and billions of dollars go in developing these new varieties. Everybody knows this genetic engineering and crop breeding. There are breeders, there are scientists, and therefore it's important. So the importance of the study, therefore it's important to know, do farmers even care about these attributes? What attributes farmers care about? You develop something, but if it's not even adopted, then it's a waste. So we want to inform policy and scientific body and these breeders and researchers that, okay, this is the attribute farmers value more. So maybe you should try incorporating this particular attribute. And that's where discrete choice experiments are useful. The other question would be that why are we using a discrete choice experiment? There's so many other methods in economics. Why can't we use them? But for products for which data is not available in the market, they're not there in the market. Some varieties are released, but they're not commercially available. We don't have data. And therefore, we have to design an hypothetical experiment, which here we are calling as discrete choice experiment. And as we have already learned that these are hypothetical. So we don't have to give them actual seeds. We give them scenarios telling them that this seed can have these particular attributes, and will you be willing to adopt it? How much will you be willing to pay for it? So that's where discrete choice experiments are useful. And the other policy related question is that you may develop hundreds of technologies, but if there are no takers, the benefits are not going to be realized. So adoption is also important. Just because you develop something doesn't mean that people are going to adopt it. And related to this is, this BT cotton, maybe some of you have heard about it. These are genetically modified crops. So this is also the time when I was interested and I was doing some research in genetically modified crops that this is the most contentious topic globally. Countries have taken positions. US has taken a position that we are going to allow genetically modified crops. The major markets are, most of it is GM. Europe has taken a position that we are not going to allow genetically modified crops. And this is the time when India is thinking about, what do we do? We want to go with the world. So what India did, it allowed these in the cotton, which is called BT cotton, and over 90% of cotton which is available in India is genetically modified, it's BT. But India didn't allow it in food. So we are having this policy for both, also seeing what's there in the US and also going with Europe. Okay. So I was interested in trying to figure out, we actually did one lab experiment with Sujoy Chakravarti from CSP and Bharat Ramaswamy from ISI to find out, do consumers care about genetically modified foods? Are they willing to try them, to taste them? After doing that experiment, the next question was, what about farmers? Will they be willing to sow these kind of crops? So we went with that question in mind, and I'll tell you that why we couldn't ask genetically modified question within our experiment, and I'll tell you why, and why the focus group discussions are important. Okay, I think I'll skip some of these, otherwise I'll not complete in time. So the objective of this research was to understand what are farmers' preferences for certain attributes, and we were particularly interested in attribute drought tolerance and submergence tolerance. Okay, so we collected data through discrete choice experiment, and also we did a survey on household characteristics. As we have learned, discrete choice methods are stated preference methods where we present a series of alternatives to respondents and they have to choose one of them. And from these choices, we infer their preferences. Okay. Yeah. So a couple of things which were, talked about in the last class also, something like consequentiality. When you're designing these experiments, you have to be careful about a few things. One, that respondents should believe that their answers have some consequences. It shouldn't be just like saying anything. So you have to convince them that these results will be presented to policymakers and maybe policies will be formed, depending upon the results from our study. So they must believe. And also the scenarios that you present to them, that should be something they can relate to. And when we did focus group discussions, we found that farmers had not even heard terms like genetically modified. So there was no point including an attribute which is genetically modified. Farmers don't even know what is GM. Okay, so I'll tell you how we framed it. We framed it differently without using that word. And another thing which I want to bring about to all these researchers here, that one has to be, whenever you're doing surveys, whenever you have human respondents, you have to be careful about ethics. So there is an ethical review committee. We have it in JNU, and it's a serious business, because you can't just ask somebody anything you like to ask. You have to keep into mind that there should be honesty in what you're doing. You have to explain to the people that what the study is about, and very important, you have to take the consent. You can't force anyone to give you data and to give you an interview. So you have to take an informed consent that this is what the study is about, and do you consent to give us? And there is a whole process in JNU. I mean, it takes more than 6 months to take that approval, but it's also important and it's also a requirement. So all PhD students, if you're planning to do any kind of survey, you need to take permission from IERB. That's what it's called in JNU, Institutional Ethical Review Board. And they'll go through your proposal. They'll go through your questions. Your questions should not be leading. Sometimes you may ask something that could be sensitive, communal wise, or something else, or religion, or other things. But you have to be careful, and committee will give you an approval after going through your questionnaires. So that's an important part of any kind of survey. Okay. So we have to do, look at the attributes and levels very carefully. And for that, you have to do a lot of things. You do focus group discussions, not with the participants or your respondents. So you should be doing FGDs somewhere else, not to the same group. So you try to find out what do farmers care about. And then other thing, here we did it, we met a lot of scientists, International Rice Research Institute and other scientists who were actually doing these breeding to understand what do farmers care about. And we found out that GM, they haven't even heard. Yeah, if I go to Odisha, a village in Odisha, and ask them genetically modified, no point. But we also find out that they were very interested in crop varieties which are short duration. So instead of the full 3 months, if you could produce crop in about maybe less than 4 month period, so in about 90 days, farmers really wanted that, because that will give them a window to maybe grow another crop. Or that'll give them some time to go and do work outside their village, migrate and do some work or farm work and earn some income. So this is something that we hadn't thought about it earlier, but after focus group discussions, we found that that's an important attribute and we included it. So now I'll just tell you what are the attributes that we considered in this study and how we did the designing. Okay. So obviously, farmers care about yield, productivity. How much, a new seed, how much will be the productivity? But how do you tell productivity? And here comes, novelty and creativeness of researchers, that how do you even present this productivity thing to it? Because it's not just about mean productivity that we're interested in. We are interested in how will this productivity get affected if there is a drought? How will this productivity get affected if there is a severe drought? How will productivity get affected if there is floods or severe floods? So we thought about how to just model our yield variable. And my students who have done microeconomics with me, I do cover concepts like stochastic dominance. So here we used that concept of stochastic dominance, when one distribution stochastically dominates another. But of course, I'm not going to use the term stochastic dominance with the farmers. So I'll show you that what we used, but what is the economic theory behind it. So, everything should be grounded in economic theory. You just don't have, randomly you can introduce your attributes. Okay. So this is like about my yield variable, how I'm going to present this yield variable to farmers. So I consider a reference variety, the rice variety that they are growing already. So during our survey, we asked them what is the rice variety that you're growing. And this rice variety gives yield of, just look at the first column. 53 quintals per hectare under normal conditions. But if there is a drought, it'll just drop down to 22. And if there is a severe drought, it'll drop down to 6. So that's the reference variety. So we say that, okay, what is, we find out what is yields under reference variety. And then when we give them another alternative, which I call first order stochastic dominance in my mind, but I'm not going to say that to farmer. And we say that, suppose there is another variety that gives you more under all 3 conditions. Under normal conditions, under drought conditions, and under severe drought conditions. So that's an alternative option. Then the second option is, which I'm calling second order stochastic dominance. It gives you same yield as the reference variety under normal conditions. But if there is a moderate drought, your yield is better. You don't suffer as much. Instead of 22, now you're getting 32. But if there is a severe drought, your yield gets better, but not too much better. Okay. So instead of 6, you're going to get 16. Okay. Then I also give another option in which your yield will be as good as reference variety under normal conditions, but you can see that it will be under moderate drought conditions, the yield will be same as the reference variety, but under severe drought conditions, yield will be better. So this last is more useful if you are expecting a severe drought. Okay, so that's how we present yield to them. Rather than one number, we give them a distribution. Okay. The next attribute, so last class we talked about that there are attributes and each attribute can have levels. So the next attribute we're talking about is submergence tolerance, and it says that for how many days the plant can survive if there is waterlogging, if the plant is submerged in water. And it has 3 levels. One is 0 to 5 days. The second level is that even if there is water up for 10 days, because water will recede. So if it takes up to 10 days to recede, the plant will survive. So it can survive under mild flood conditions. And our third level is if it can survive up to 15 days. And again, these number of days is not something arbitrarily. You talk to scientists and you find out, okay, the reference variety, for how many days can it survive? And then you talk to scientists that, okay, you're developing new variety, and actually during that time, a new variety had come which was called sub-1, submergence 1, and that variety could tolerate waterlogging up to 15 days. So everything has to come from scientific evidence, and it's not that you can do things whichever way you like. And this is short duration, the duration attribute I was talking about. So in short duration, less than 120 days. Normal crop would be about 135 days. From planting the seed and till the time you harvest it, it takes about 135 days, 4.5 months. Okay. There are some short duration varieties, and there they can give you results within 120 days. Okay, 4 months. And there will be something like medium duration, which is 120 to 135 days. As you can see, it's, you can't change things drastically. From 135 days, you can bring it down to 120 days. But you can't say that within 1 month, I'll plant and I'll be able to harvest. So again, all this has to come from scientific evidence. Okay. Then I also include an attribute which I'm calling as a seed type, which can take 2 levels. One is that seed can be stored and reused next season. In traditional farming, what do farmers do? Whatever harvest they have, 10% of it or some percent of it, they'll store it and use it as seed next year, and rest they'll sell in the market or consume. Okay. But we also know that there are new seed varieties which cannot be used next year, and you have to pay royalties every year if you want to use them. And genetically modified seeds are one of those. You cannot reuse them. You've planted them once. If you want to plant next year, you'll have to buy a fresh set of seeds, because the company which has developed them, that gets royalty. That's how they make money out of it. Since we could not use the word GM, we rephrased it and talked about in terms of whether it can be used next season or it cannot be used next season. And hybrid varieties, so we know that in wheat, most of it, the green revolution brought in hybrid varieties. Okay, and then we chose a number of price levels ranging from 15 to 300 kg. And, this was not done as sophisticatedly as we discussed last year. So the way we thought about it was, went to the market, saw that for a conventional rice variety, seed price was about 15. And for hybrid varieties, for the most expensive varieties, prices went up to 250. So we just took a little bit more and made it a 300. Okay. So that's how various attributes and levels for each attribute. Okay, maybe I'll here take a few questions if there are any. Okay, but very briefly, because I want to cover this whole paper. Yes, there are a couple of questions. Yeah. Okay.
Ma'am, I have one question, that is how you came out with that first order stochastic dominance, because you wrote the yield in the sequence, right? First, second and third. So how you came out with that figures of yield in different levels? Did you use some modeling on it? Or it was from any scientific community?
Yeah. It is, so we look at the reference variety. Okay. Because for that we have evidence from the market. What are yields in a normal year? What will be the yields in a drought year, and what will be the yields in a severe drought?
So this is the yields for a specific variety you are talking about?
So the variety which was normally used in Odisha at that time. I also have names in my detailed paper, but yeah. So you go and you survey. They were using one particular conventional variety, and what were the yields that we got from the market data. And then we go to scientists who are developing drought-tolerant varieties, and we ask them, okay, what do you expect? How much improvement? It's not like it'll be a drastic improvement, but how much improvement can there be? And that's how we got these yields.
And I have another question on, you said about seed type, like for hybrid, you have used hybrid as an instrumental variable for referencing it to GM, right?
Not really instrumental variable, but you can say as a proxy.
But
I mean, it's not an exact proxy or anything, but since we couldn't use GM, so I'm not going to present results saying that it's GM, but still there is a difference in preference. If seed is if you can use it next year, that means you don't have to spend on seed next year. So that's the trade-off. yield versus cost saving next year. That's what we are going to capture here.
But ma'am, because why I had that question of hybrid, because there are many hybrids apart from GM in the market.
Yeah, of course.
There are plenty of hybrids
There
actually.
are plenty. Yeah,
So it's
that's
very
what
hard to-
farmers know. No, I'm not. I'll never, present my results saying that this is valuation for GM. I was telling you the motivation.
Okay.
How we started, but we couldn't find out valuation for GM because it was not possible. But we could find valuation for hybrid. Okay. What's your name?
Sumit Sutradhar.
Oh, okay. Yeah. Thank you for your questions.
Hi, I'm Tanu. I had one question. You mentioned about consequentiality, where you said that we would actually be telling the respondents about how their responses are going to be kind of narrated to the policymakers. But when I was conducting a survey, I found that once we tell them that how it is going to be translated to the policymakers, like let's say if I was discussing about the public distribution system or something, they would actually try to kind of give me a kind of narrative which is, let's say, they were very pessimistic about policy schemes in that regard. So once we tell them that if we give this narrative to the policymakers, maybe they might not reveal a true picture or something. Did you face this something of this sort?
Okay. Khushi, Adan wants to respond to that. So.
Also, you mentioned this one more question. You mentioned about focused group discussion, and you said that you are taking a different group. In terms of you'll do some this kind of thing discussion with some other group. So in your regard, did you take the discussion with scientists, and how helpful was it to kind of to figure out the actual this thing survey for the farmers?
Okay, thanks Tanu. Adan, yeah, you want to respond?
Thank you for the question. So that is a very good question, something we have not covered. Of course, as let's say that consequentiality is a requirement that economists have come with theoretically. Theoretically, if you don't transmit consequentiality, you cannot say that people are going to be willing to reveal the truth. So remember, the idea is to simulate a market as serious, as realistic as possible, and that is consequentiality. That's why consequentiality is important. The story that you are telling relates to the fact that we don't know whether people are going to be revealing more or less willingness to pay, whether people under consequentiality are going to be saying, oh yeah, I love it because I have a lot of hope that it's going to become a policy, or oh, I don't believe that this is going to become policy if we put it with the policymaker, and then I am going to just pay this. Theoretically, we don't know what is going to be the effect of having something consequential. There is some studies showing that actually it can go both ways. In some contexts, when they have done split samples with and without consequentiality. And they have shown, with consequentiality, people reveal higher willingness to pay, state with higher willingness to pay. In another context, with consequentiality, people state lower willingness to pay. We are right now with some colleagues studying willingness to pay for adaptation in Europe, in 7 countries of Europe. And those people that actually we communicated consequentiality and believe that there was going to be some consequentiality are revealing incredibly high willingness to pay for adaptation. And I say incredibly high because we have been estimated as percentage of their income, and it almost reached 20% of their income, which is difficult to sell and to believe. Those people that didn't believe in the consequentiality were revealing lower willingness to pay. That is more realistic. So, to summarize, this is a great question. Please think on always adding consequentiality and keep up with the literature, because as of today, we still are discussing best ways to phrase consequentiality, and also whether we should have a strong opinion on whether once you express consequentiality, it should deliver higher or lower willingness to pay, or you should have an idea. And right now it's an open question in the methodology. So what you are describing, it happens. And so far, the recommendation is still add consequentiality, even if people are a little bit too critical of the possibility. That is the recommendation, even if it decreases the willingness to pay.
Yeah. Any other question? Yeah, Aishwarya.
Ma'am, continuing with what Tanu asked, so you said you have taken scientists as the focus group. So how should we?
No, I never said that.
You have spoken
I'll
to
answer
scientists.
that. I'll answer that. Any other question?
So, ma'am, just how do we select the focus group for a particular experiment? So
Okay.
that's the question.
Yeah. Yes, you can ask.
Thanks.
Thanks,
These
Emina.
attributes like duration, is it mutually exclusive to say flood, submersions, and drought resistance, or they are the same varieties?
No, it's that attribute is different from submergence tolerance and drought tolerance.
Means these are normal varieties duration.
Okay, I'll just explain that. Yeah.
Ma'am, for drought tolerance attribute, when we were referring to levels for first order and second order, what was the trade-off for people?
So that'll come in the results part. Right?
Okay.
Yeah. And maybe I can just respond to focus group discussion. Thank you for all the questions. So yeah, it's not that you can do focus group discussions with the scientists. You have to do focus group discussions with farmers, but I'm just saying that I'll show you that we chose 3 districts in Odisha. So for focus group discussions, I can go to another district within Odisha, so that which also experiences similar conditions. So that is where I'll do my focus group discussion. And about attributes. So each attribute we are seeing as a different characteristics of the crop that they're going to. So short duration is another characteristics. Okay, so Pranav, are there any online questions? But maybe I can take that later. Are there any? No? Okay. So I'll just continue. Yeah, I think that was a good discussion, that what are these attributes and what are levels for each attribute. Okay, so yesterday some of you were very curious about how do we do it and what is the theory behind it. So I just put a few slides together for econometric and economic theory behind it. Those of you who are from other disciplines, it's okay, you can skip it, but actually my class is missing today. In the morning half they have classes, so some of them not here, those who had asked those questions. Anyway, they can go through them. So the basic model that we are going to use here is a random utility model, and which says that utility that any individual gets from a particular product, that depends upon, and that can be written as a function of observable attributes of that product and maybe characteristics of the person, which is x, nit, and beta is the coefficient. So xi are vector of attributes. All those attributes that I talked about, they are observable and I can include them, and beta will be the marginal utility of attribute in this form, because if I do del u by del xi, I get beta. And now this epsilon is the unobserved part of the utility, residual, and everything gets subsumed in epsilon, and it will be stochastic in nature. You can also see that utility is something that a researcher cannot observe. So if I do a survey, I cannot observe utility, and we call it a latent variable, something that's there that is guiding the decision, but I cannot observe. As a researcher, what can I observe? I can observe which alternative did they purchase. For a specific alternative, Was it 1? Did they purchase it? Did they choose it? Or was it 0? And the economist in me is saying that it's going to be 1 only if I prefer that alternative to all other alternatives that are there. So if I give you 3 choices and a respondent chooses one particular choice I, what do I infer? That the utility that this person is getting from I is larger than utility from other alternatives, alternative B and C. Okay, so that's economic theory behind it. And then we can figure out what is the probability that this person is going to choose alternative I. That probability will be if the utility this person is getting from alternative I is larger than the utility the person gets from any other alternative that's there in the choice set. I can do a little bit of manipulation and you can see that how this just comes to cumulative distribution function. This is nothing because these are random variables. Epsilons are random variables and probability that a random variable is less than certain value, that's CDF. So starting from a utility function, I've already come to CDF, and we also now need to assume what is the distribution of epsilon. And if I assume that epsilon is distributed extreme type 1 or Gumbel distribution, then there is a result that the difference between two of these Gumbel distributions is logistically distributed. So you can see that how easily from my utility function I've come to logistic function, and that's why I can use logit models. And in a conditional logit model, probability that an individual is going to choose an alternative I will be simply given by this ratio. And what is this ratio? These are all observables. So I can now estimate this probability, and that's what we're going to do it. Okay, so there was some question that how do we move from here to here? It's this pretty simple economic theory behind it. Okay, so this is called conditional logit because what I'm going to choose is conditional on the attributes of the product and my own preferences, depending upon maybe how educated I am, what is my income, whether I live in a rural area or urban area. There could be so many things about me. So that's why it's called conditional logit. But conditional logit has two limitations which we talked about, but I'm just repeating here, that it assumes that preferences are homogeneous across all respondents, which is not true in reality, so we'll need to refine it. And it also assumes independence of irrelevant alternatives. And I'll just, it's very simple to see how independence from irrelevant alternatives, because if you take ratio of two probabilities, see, P and I by P and K. So consider two alternatives I and alternative K, and if you take that ratio, the denominator will get cancelled. Oh, which one? Is it off? Hello? It's not working. Thank you, Kushi. I hope you were able to hear me and everything hasn't gone waste. Okay. So here I was showing you, if you take a ratio of probability of buying alternative I and probability of buying alternative K, the denominators will cancel out, and it's just exponential of the observed part here and the observed part for K. And this is called independence from irrelevant alternatives. What is my preference from other alternatives? That doesn't even feature here. Okay. Right. So we move on to a more sophisticated model, which is a mixed logit model or random parameter logit model. And this model takes care of both those limitations. So here we allow for preferences to vary across individuals, right? I have a different preference, you could have a different preference. My model allows me to do that. And now we don't even need to assume independence from irrelevant alternatives. So this is the model that we'll be estimating most of the times. Okay, and the probability that an individual I is going to choose, individual N is going to choose alternative I will now be given by this expression. Okay, so this is like, these details are for people who want to really learn the econometric theory behind our estimations. Okay, so we need to now describe distributions of all our attributes. We'll normally assume that these coefficients are distributed normally, and we'll keep the coefficient of price to be fixed. That makes it simpler to work out the willingness to pay coefficients. Okay. So this I think I already said that beta i's are marginal utilities. So when I'm going to estimate, estimate marginal utility for alternative I, for attribute I, and similarly I can estimate marginal utility for attribute K. And now you can see that if one of these alternatives is price, if one of the attributes is price, and when I take two ratios, that'll give me marginal willingness to pay. So after my estimations, I just need to take a ratio, and that ratio will give me marginal willingness to pay. That's what we are going to do in both applications. Okay, yeah. This is simply willingness to pay is the ratio. Okay, about the experiment. This experiment was conducted in the months of June and July in 2013 in Odisha. And we are from India, so we all know Odisha is in the eastern part of India, and you can see that it's along the coast. So a lot of monsoon variability it suffers from, and there are often floods. So this is one of the states which suffers from both kind of natural calamities. There'll be floods and there'll also be droughts, and therefore it made sense to do this experiment in Odisha. And also this is a state which primarily grows rice. Rice is the staple crop there, and farmers are interested in rice. And we conducted this experiment in 3 districts of Odisha: Cuttack, Dhenkanal and Jagatsinghpur. And as you can see, this Jagatsinghpur is on the coast. So this is a district that suffers more from floods. And in the interiors, this Dhenkanal, it's again, mic is not working. Aapka mic mein bahut problem ho raha hai. Can you? So should I speak here? I'll speak here. But I'll need the, Acha, it's here. Fine. So Dhenkanal is one of the districts that suffers from drought, and Cuttack is a district that suffers from both floods and droughts. So these were the 3 districts we chose for our experiment, and for our focus group discussion we did somewhere other than these 3 districts, but with farmers. Okay, so yeah, this is a sampling, etc. So finally we did for 400 rice growing households in these 3 districts. Attributes I've already explained to you, attributes and levels. So it's just putting everything together. These are so many attributes. 1, 2, 3, 4, 5. We had these 5 attributes, and each attribute had certain levels. And as you can see, levels don't have to be identical across attributes. For price I had 6 or 7 levels. For seed type I had just 2 levels. For other things, I had 3 levels. So levels can differ across attributes. If I used a full factorial design, you can see that would mean 324 choices. You just need to multiply all the levels and all the attributes. That's not practical, that's too large. So we did what we learned in the last class, fractional factorial design, and that will bring down my choice sets, maintaining the efficiency. So finally we came up with 36 choice sets, and these 36 choice sets were, hello, can you hear me? Yeah. So these 36 choice sets we further divided into 4 blocks, so that you don't want to present 36 choices to one individual. That'll be like fatigue. Nobody wants to answer. People will say, no, I don't want to take your survey. If you give them 7, 8 or maybe 9, they'll still do it. Okay. So to each farmer, we presented 9 of the choice sets, and they had to choose one of the alternatives that we presented to them. Okay. So this is like, this is when we say that you design, this is something you'll have to show us. That's how you present a choice set to a farmer. What does this choice set has? You can see it has 4 options. Usually one has 3 options. I became too ambitious and included 4 options, and then when you do mechanics it becomes very difficult. So I'll not recommend, but anyway, this was my first discrete choice experiment, so I had these. Rice seed A, rice seed B, rice seed C, and you always include an option that no, I don't care about your options, I'm happy with what I'm doing. That's my current seed. Okay, that alternative we always include. Now, you can see this is not an alternative specific experiment, because I'm not giving names to seeds. I'm just calling them A, B and C. Okay. So, what is my choice? I have to choose, as a farmer, I have to choose A, B, C or D. One of these I'll have to tick. Okay. What is A? A says that your seed is long duration seed. It will take 135 days for your crop to mature and ready for harvesting. Its yields will be 53 in the normal air, and you can see, the illustration, water tank, full water tank means normal air, normal monsoon. Half water tank means mild drought conditions, and an empty water tank means severe drought conditions. So that's like, you want to illustrate and you want to communicate to them with pictures, and especially if you're doing it with farmers. It also depends whom you're doing the survey with. Okay, so not only water tank, we also had this picture of drought, Okay, then the attribute submergence tolerance, and as you can see here in alternative A, it's 5 to 10 days, and we store water and your crop is under water for 5 to 10 days. Then the attribute whether the grain can be stored and reused as seed next season. So we show them that there is a storehouse and you can store your seed. And in the last alternative, cross means you cannot store it. Okay, so this is just visual interpretation. And then price. So for this, you have to pay 25 per quintal. For option B, you have to pay 300 per quintal. And for option C, you have to pay 220 per quintal. So this is a kind of choice card we are going to show them. And we say that pick up one of these. Okay. So yes, whenever you're doing this, it's important to also have some pictures to show that you actually did it. It's not that you're sitting in Delhi and got it. Okay. So this is like, farmers in Odisha, and towards the right is Achal, my student, and this guy is the enumerator, because all the survey has to be translated into their local language, otherwise they won't even understand. And this is a particular household. We're talking to them. So this is like pictures from actual survey that we done. Okay. In terms of, writing down that equation, UIT, we can write it like this. So you can see that each of the level will enter my equation, and then I can econometrically do my estimations. Okay. How are we doing on time? Okay, I think I can take 5 more minutes and at least complete this paper before we break briefly for tea. Yeah, I'll skip some of these, but I just want to talk about the results. We did find positive and statistically significant willingness to pay for productivity increasing. That's very obvious. If you tell farmer that your productivity will increase, they'll be willing to pay more for that. But there was also willingness to pay for risk reducing attributes. So this drought tolerant and flood tolerant, that's a risk reducing attribute. In normal years, I don't care whether my seed can tolerate drought or not. If there's no drought, it doesn't have any additional benefit. But I might buy it because I want my risk to be reduced. I don't want, if there is a drought, what? Then I don't want my crop to fail and I'll have no income. So that's why these are called risk reducing attributes. And we found that for Odisha at least, willingness to pay for drought tolerant trade was higher than the submergence tolerant trade. But an interesting result was this. There was considerably high willingness to pay for short duration variety. And there could be a couple of reasons for this. That maybe farmers want to skip droughts, because if your variety is a short duration variety, even if monsoons are delayed, you can still sow your crop. Or maybe between 2 crops, you get a window where you can produce some horticultural crop, which will give you some quick results. Or maybe many of them wanted to do off-farm work. So if you get 1 month, you can go to cities or some other place and do some work. As we know, the agriculture in India is very seasonal. So most labor, during harvesting time, they'll go back to their villages. But during lean periods, they go and work in other places. And then we also find negative valuation if seeds cannot be stored and reused. Obviously, you would like if you can use your seed next year. Okay, but there was a very large heterogeneity in the distribution of this willingness to pay coefficients. Okay. So then we just try to do, farmers. What about farmers in flood prone regions? What do they prefer? And what do farmers in drought prone regions prefer? So we said that farmers in the flood prone region, they had a positive willingness to pay for long-term submergence. But they were also, they also valued drought tolerant trade. Okay, this is what, I think Adan has been telling me to do the demand curves. So, and this is novelty and contribution of the study. Most discrete choice studies, if you see in the literature, are not able to estimate the demand curves. But here, we were able to estimate the demand curve for a seed with particular attribute. So if you see the solid line, that is some seed type A. And this seed type has certain attributes, like its short duration. Do you see the attributes I've written here? So this seed type is short duration. It's inbred and it has first order stochastic dominance attribute. And you can see that the other seed type is medium duration, which is inbred, and it has submergence tolerance for 10 to 15 days. But clearly the demand is much higher for seed A1. And these demand curves are, as we expect in economic theory, downward sloping, monotonically downward sloping. And that provides some external validity here that what we are estimating makes economic sense. It's not like you estimate something. After those estimations, using those estimations, I was able to draw the demand curves. Okay. So another example of this demand curve. So what do you need to do? You specify certain attributes. And then you want to find out what percentage of population is willing to buy it at what price. And that's something which is informative. That's something you can inform to whether scientists, breeders, or policymakers. So again, I have these two seeds, and you can see the solid curve for the same seed attributes. This is percentage of adoption of that A1 seed in the drought prone area. And this broken curve or dashed curve is percentage adoption of the same of that A2 variety in the flood prone area. So not only I can determine overall demand, I can also determine demand in specific regions. And then you know that, okay, so if the price is like about somewhere about 8 to 900 per quintal, then only 20% of the farmers are going to adopt it. But if the price falls to maybe 400, then a large number of farmers are going to adopt it. So suppliers looking at these demand curves can decide whether they're going to which seed variety should they produce, which attributes to include. Okay. Yeah, some highlights that we did find that farmers value reduction in yield variability, and they were willing to sacrifice higher yield under normal conditions. And for India, this drought tolerance trait was more valuable. And maybe that's also something we can relate it to it, because a lot of crop gets damaged due to droughts. So we could find that in our results. But the additional result was also valuation for short duration attribute. But these valuations varied considerably across farmers. I think we can stop here for a quick tea break, maybe 15-minute tea break. There is one online question? Okay, I'll take that. So maybe you can use this mic, read it. I'll use the other one.
Good morning, sir. Sir, you may ask your question.
Is this Nirmal?
Yeah.
Okay. Hello, Dr. Nirmal. Or perhaps you may
Sir,
just repeat it.
Sir, I think your mic is not on. Hello. Yes, sir.
Can you hear me?
Yeah, now fine.
Or perhaps you may just repeat it.
Okay.
Sir, I think your mic is not on.
Professor Bansal.
My mic is not working?
No, fine. Yeah, sir, you may ask now.
No, he wanted to say something.
So, Professor Bansal, thank you very much for that insightful presentation of your work. So, I was kind of wondering when you set the labels for each of the yield varieties. So, are these labels kind of fact-based, or they are just hypothetical labels that you came up with? Because you see, like I'm not sure. For example, in the choice sheet, let us say that your first variety is FSD, right? So let us suppose that the submergence tolerance for FSD lasts for like 0 to 5 days, right? So I'm not sure whether that is true or not. Just for an example's sake, so in some choice set, so when you do create the choice sets, like out of, let us say, the 36 choice sets, so some choice set, for example, may have this attribute submergence tolerance for FST, which might have a label of, let us say, 5 to 10 days. I'm not sure when you do that, de-efficient design. So if 0 to 5 days is for FST, so in some choice sheet, I'm not sure whether it's possible or not. It comes out to be, it appears to be like, for FST, 5 to 10 days in case of submergence tolerance. So I'm not sure whether you are getting my point or not.
No, I am. Thank you very much for that question. And
Yeah.
so
Yeah.
when we are choosing levels, we do it scientifically for each attribute. So that's, we met scientists, we collected data from the market, and those levels were chosen from scientific evidence. But I see your point that when you're combining this, you're asking me that, is there a seed which has FSD and long duration and, I think that's what your question is about, right? Is that right? That is it possible to combine submergence tolerance 5 to 10 days with the long duration and the yield that I'm reporting here? Is he able to hear?
Yeah, yes, ma'am.
So is that what you're trying to ask me? Yeah, that I cannot say. That's hypothetical. The combination that turns out after we are doing this, designing these choice sets. So that combination of a seed is available somewhere or not, that I don't know. But when I choose levels of my attributes, that was based on scientific evidence, and from their choices, now I would just want to, find out their valuation for different attributes. Do you want to add that?
Probably what I will add is that if there is one of the combinations that for whatever reason the researcher thinks is important to have it there, then we keep it there, right? Like you identify and you say, keeping this one here, this combination, I am going to play with the other ones because they are not that relevant. But in general, once you estimate the willingness to pay or the value for every one of those attributes, you could infer what will be the value of a given combination. And I am going to talk about that in one of the slides in the next session. But basically, whenever you are interested in one of those combinations, you could estimate the value for those combinations coming out from the coefficients that you are going to estimate. So even if you don't include it explicitly, you could infer the value for it later on, but you could want to keep it there.
Okay, so now I think we'll have a short break, 15 minutes break. We'll have quick tea and come back to the next session.
Previous session we had covered the paper on the discrete choice experiments related to climate change on the rice varieties. So what was the willingness to pay for the farmers? So this is the paper again related to the transportation sector, but in this paper we'll be covering the willingness to pay for the labeled cars. So this study was being done in 2017, So it was prior to the COVID period. And this paper has been recently accepted in the Transportation Journal. And the paper is already uploaded on the Google Drive for you all to read. So this is the title of the paper, The Preferences for the Energy Efficient Cars in Delhi, using a discrete choice experiment, and where we are exploring the regulatory and the non-regulatory interventions. This is a joint work being done by me, Adan and Sangeeta ma'am. So all three of us had done this paper and it will be coming in Transportation Journal. So before going into the dynamics of the discrete choice experiment, first I would like to motivate, like why did we did this study, what are the implications, and then we'll formally talk about how did we design our choice experiment. So we all know air pollution is affecting your human health, climate change. So its implications, and these implications is a major issue in mega cities, especially Delhi. I think from last few months, starting from October itself, the AQI is above 300, sometimes above 400. Every alternate day, GRAP 3 measures are being introduced in Delhi, then removed. You all know it is affecting the health, even the students' classes turn online. So that is what we are trying to capture in this paper. How can we reduce air pollution? So in India, the transportation sector is accounting for 72% of the emissions are coming from the transportation sector. So smog in Delhi is coming from the crop burning, from industrial pollution, vehicle emissions. So this paper is trying to target how can we reduce the vehicle emissions which are coming from the transportation sector. So a popular strategy to reduce the vehicle emissions could be that we say follow fuel efficiency standards, or we could follow fuel efficiency labels. So we have these kind of the standards and labels for appliances. So in India, we have Bureau of Energy Efficiency, which is looking about for these energy efficiency labels. So like say you have air conditioner. You all would have seen a star labeled on an air conditioner, ranking from 1 star to 5 star. On refrigerators, even on laptops which you would be using today, you all have a star label on these. So then why not have these labels on the cars also, to indicate that this car is more fuel efficient as compared to the others. So we have these standards for appliances, fuel efficiency standards for cars. So we are proposing that government should consider having fuel efficiency labels. So in the Global Fuel Economy Initiative, the government has proposed these labels, but they are yet to be implemented formally, have these labels. These labels are already there in the developed countries, but not much adopted in developing countries, especially for cars. So in New Delhi, my focus area is within India. We are focusing on Delhi because in Delhi the emissions are very high. We had the emissions of 2.8 million tons of CO2 in 2021. Total number of registered vehicles in Delhi were 11.4 million. These number of registered vehicles are much higher than the number of vehicles we have in Chennai and Mumbai combined. So combining the two states, the number of vehicles in Delhi are much higher than that. The PM 2.5 level in Delhi is 30 times more than the level what WHO considers safe. So in the paper by Sangeeta ma'am had actually estimated if the PM 2.5 level, it reaches to what WHO considers safe, my life expectancy is expected to reduce by 10.3 years. So that is the impact which you can have if you are improving your PM 2.5. So if you are reducing the CO2 emissions. So taking this into account, so this is an example you can see for a fuel efficiency label. So it is ranking from 1 star to 5 star, where 5 star indicates that it's the most fuel efficient car. Then you have least fuel efficient car will be your 1 star labeled car. So this is an example where it is giving the information related to fuel economy, with a petrol variant, how many kilometers per liter, mileage information. So that kind of providing the information. That is the idea of these labels. So to consider these labels, what is the willingness to pay for the consumers for these fuel efficient labels? In my study, we use a methodology of discrete choice experiment. So as ma'am highlighted in the rice paper also, the data was not available. So similar issue we were facing in this, that there is a lack of the data. So we tried to design a discrete choice experiment. The objective was to analyze the consumer's willingness for the fuel efficiency labels in New Delhi. So while designing this discrete choice experiment, in this paper, we added 2 novelties to this paper. First was, we wanted to see the impact of some regulation which is being imposed. So like what policy implications you can design from that. So Adan had already covered about this in his lecture, but I'll explain it in more detail. So what regulation we have? So we gave them a regulation like an incentive. So how with that incentive your willingness to pay will increase for the efficient cars for the labels. And the second novelty which we introduced was, we wanted to explore the impact of behavioral motives. So how your motives, is it your internal urge to contribute towards the environment? Are you really concerned about the environment? Is that making you buy a more efficient car? Or say, is this the impact of your friends, your peer group, your colleagues, neighbors? So is their impact making you buy a more fuel efficient car? So we introduced 2 novelties in this paper. One was where we covered the impact of regulatory incentive, and second was behavioral motives. So I'll go into the detail of both the novelties and show how we had modeled these novelties. So first one was the regulatory incentive. So in Delhi, you all are aware of the odd-even scheme which was being there in Delhi. So in 2015-16, this odd-even scheme had been introduced, though it's not introduced in the recent times, but this study was done in 2017. So during that time, odd-even scheme was more popular. Now also it keeps on coming that they might impose this odd-even scheme. So what we have in this odd-even scheme? So your odd-numbered registered plates cars would be allowed to be driven on odd dates. Even-numbered registered plates cars will be allowed to be driven on even dates. But we added a twist to this regulation. So what we did was, if you buy a more fuel efficient car, then you are exempted from this odd even regulation. So like if you buy a high star, say a 5-star labeled car, you can drive it on all days, irrespective of your, whether it's your odd numbered plate car or a even numbered plate car. So to employ this strategy, we followed a split sample approach, which Adan had already highlighted, a split sample approach. So what we did in this split sample approach is, we informed half of the respondents about this regulatory incentive. So we informed half of the respondents that if you buy a high star labeled car, you can drive it on all days. There will be no regulation which will be there for you. But for the other half of the sample, there was no incentive being given to them. So we divided our samples into two halves. For half sample, there was an incentive scheme that we call it as an informed sample. They are informed about driving restrictions, and the other half there was no incentive. So this is similar to a scheme which we have it in Mexico, like Mexico Ho No circular scheme, where you are not allowed to drive the cars on all days. There is a kind of a restriction, driving restriction, which is being imposed. So that was the first novelty of this paper. And New Delhi residents were already familiar with this odd-even regulation. And second was the behavioral motivation. So if we compare our studies with the previous literature, the previous literatures in developed countries, they have talked about how the labels, what is the willingness to pay for the labels, for the fuel efficiency labels, as well as for the energy labels for the appliances. But such studies are not there for India and especially for Delhi. Plus, in addition, the second is, none of the previous studies, even in the developed countries, they have tried to combine labels with the incentives. So that's the one of the novelty, that we combine labels with incentives. And in addition to that, we also see the impact of the behavioral motivations. So this is just a newspaper article on the odd-even rule on day 1. It's a 2016 article when the odd-even rule was introduced. So I have explained how we incorporate the behavioral the regulatory incentive. The second part which we are incorporating is the behavioral motivations. So how your friends and peers impact your choices. So to incorporate the behavioral motivations, we asked the respondents with the Likert scale questions. So it's like a Likert scale ranging from 1 to 5. Where 1 indicates strongly disagree, 2 will be disagree, 3 is like undecided, 4 agree, and 5 would be strongly agree. So ranging from strongly disagree to strongly agree, we ask the respondents to rate on a Likert scale. So regarding the behavioral motivations, I grouped those behavioral motivations into 4 categories. One was your intrinsic motivation. So it's like your warm glow effect. Give something out of the act of selflessness. What is your internal urge to contribute towards the environment? So that was the first behavioral motivation which we covered, was intrinsic motivation. So we asked 3 questions for intrinsic motivation. So a couple of questions were asked on each of them. So in intrinsic motivation, we asked the respondents, I feel personally obliged to save energy. So rank them on a scale of 1 to 5. While purchasing household items like air conditioner, do I take into account how my use will affect the environment? We introduced it for appliances because these labels are already there for appliances. I am willing to purchase energy efficient star labeled electrical appliances even if they are more expensive. So you all know, like if you buy a labeled alternative, a 5-star labeled car or a 5-star labeled appliances, they will definitely cost you more. But at the same time, you will have some private benefits in the form of energy savings, fuel cost savings which you can derive. Plus, you will be deriving some public benefits in the form of reduce CO2 emissions. But then to buy energy efficient appliances, you will have to pay more. So, are you willing to purchase energy efficient appliances even if they are more expensive? So, these were the 3 questions which we covered on intrinsic motivation. Second behavioral attribute which we wanted to include was extrinsic motivation, which we call it as networks. So, another novelty of this paper is to see the impact of social network, green networks. So, we incorporated green networks in the form like, say, if the other consumers are buying that product, will it increase your willingness to pay? How your choices are being influenced by your peers, by your neighbors, colleagues. What happens like if most of your friends are buying an electric vehicle, buying an energy efficient car, will you buy it? So, to incorporate this, we incorporated the network effects in 2 forms. One, we incorporated it in the choice experiment itself, and second, we incorporated it in the form of the Likert scale questions for the behavioral motivations. So, these were the 2 things on the basis of which we incorporated the extrinsic motivation. So, questions were, these were 2 separate questions. I consider recommendations from family, friends, neighbors while making choices to buy cars, household appliances, and a separate question on colleagues, because sometimes the influence of your colleagues is different from your friends, neighbors. So, these were the 2 questions which are included on the extrinsic motivation, your network effect. Second way network was discussed as an attribute. We will talk about choice experiment. So, there I will talk more about the networks. Third behavioral motivation which we introduced in our study was social interaction. So, how well we wanted to document how well you are interacting. So, we documented in the form of, say, how many times do you meet your friends and relatives. So, for colleagues, obviously you will be meeting at workplace. So, we tried to change and incorporated it in the form like how many times you are meeting outside during a month. Then you can say if you are inviting your friends, relatives, colleagues to your home. So that would be like another more level of social interactions if you are regularly inviting them for dinner, lunch. So we incorporated a separate question on that. So say, how often do you invite your relatives, friends, colleagues to your home? So this was the another question which we introduced. So it's like, do you invite them, say, less than 2 times in a month, 2 to 6 times in a month, or more than 6 times in a month? So based on that, you can rank how many times you are meeting it. So this was the another novelty of this paper, to incorporate social interactions. Then within social interactions, we incorporated one additional parameter, which is the trust factor. So it's like if you trust more, that means you will be following their decisions. If you trust that, okay, my friend is buying he has made a good choice, he's buying a good car, I should follow it. So these trust factors I incorporated by these questions like, are you willing to lend your household items to the neighbor? So if you trust, only then you will be lending. Do you keep your house or car keys with your neighbor? If you are leaving home for some work, you might want to keep their car keys. Or say, sending your children to the neighbor's home. That is also a trust which you have. So we incorporated questions like, how often do you leave house, car keys or your children to your friends, to your neighbors? So that was the another question where we incorporated social interaction. So that was the third attribute, intrinsic motivation, extrinsic motivation, social interaction. Then to capture behavioral motives, we included another question of your environmental knowledge. So how aware are you about the environment? So we had shown them this energy efficient label for the appliances. So we asked them, do you recognize this label? Which agency is giving this label? So it's like Bureau of Energy Efficiency is giving this label. Some basic questions like how is soil erosion can be prevented? When is the World Environment Day celebrated? So greenhouse gas emissions is caused by what factors? So a multiple choice questions, and we asked them to give the answers to that. So with this we could actually judge how well they know how well are they aware about the environment. Do they have a good environmental knowledge or not? So these were the novelties. One was your regulatory incentive. Second was the behavioral motivations. So for these novelties, we estimated consumers' willingness to pay for the energy efficient appliances. So before I go to choice sets, any questions if you have, then I'll go further. Yes.
You mentioned that you had taken a separate effect for your friends and for your colleagues. So how was that? What was the
I have in my results I have documented it combined, but initially we thought we can actually at least take a separate effect. So there were just two separate questions. So one question was, do I consider recommendations from family, friends, neighbors while making decisions to buy your household appliances? Second, same question, just instead of friends, family, neighbors, I asked colleagues.
But what was the motivation of segregating the two in terms of social interaction?
So sometimes I wanted to see how well are you influenced by your friends, neighbors, colleagues, and especially for social interactions when you are inviting them to the home. So with colleagues you are meeting them daily already. So inviting to home is not much common, which is more to your friends and relatives.
So did you find that colleagues had more effect on
I didn't specifically go for incorporating separate impact. I just considered them as together. Any other questions you have? Yes.
About the sample, I just wanted to ask how.
Yeah.
About the sample, that's a question I always have with studies like this. That is, how do you adjust for, say for example, if you're finding people in your circles or whatever it might be, how do you adjust for the socio-economic status of the people? Because these behaviors will really differ.
I'll be talking about the sample in detail, but basically since this is for car owners, so we tried to capture those who are higher and the upper middle class people. So we specifically targeted that sample. But I'll be talking about the sampling in a while. Any other question? Yes.
These are the questions that are used as additional controls apart from the choice set which will be
yes,
present.
These are used as an additional
Okay,
control.
so all these will be categorized into different...
Yes, I'll be coming to that, how we use these variables.
Okay, thank you.
Any other question? Okay, we can continue, and then if you have more questions, we can take it later on after the choice set. So these were the few studies in the literature which had talked about the efficiency labels, how much you are willing to pay for these labels, but none of these studies had combined fuel efficiency label with the regulatory incentive, especially in this form of an odd-even rule. So this is what is the choice set. So we all know a discrete choice experiment, it's already talked about, is a hypothetical scenario. So before deciding these choice sets, we also did a focus group studies, and after even documenting this choice set, we did a pilot study to see that whether we want to change any of our attributes, how are these attributes impacting. So we did a pilot study as well as the focus group discussions to decide on the various attributes and its levels. So based on that, in our study, we decided to follow 3 alternatives. So in discrete choice experiment, we give the respondents different alternatives. Each alternative is characterized by a different set of the attributes. So that is what is required in the assignment, that you need to decide on the alternatives. You may label the alternatives or you can just keep it as alternative 1, 2, 3, 4. Generally, as ma'am said, 3 would be a good number, because more alternatives, more difficult it becomes to estimate. So you can decide on the alternatives, then decide on the various attributes which you want to keep for these alternatives, and for each attribute, what are the various levels. So you can range your levels from 1, 2, 3, 4, whatever you think is reasonable based on the literature and based on the focus group discussions. So based on that, you can decide on your levels and the attributes. So in our study, we had chosen the 5 attributes. So there were 3 alternatives. First of all, we have like 1 to 5 star, we all know. So we categorized 4 and 5 star as a high star labeled car. So that is like the best alternative, most efficient, fuel efficient car. So that I call it as high star labeled car. So it's like star 4 and 5. That is my first alternative. Second is your moderate star labeled car. So that is like a star 3, a middle range. Third could be like a status quo or a unlabeled car, star 1, star 2, lower labeled cars. Or you can say presently we don't have much of these labeled cars. So these were the 3 alternatives which we had decided in the choice experiment. They were characterized by these 5 attributes, starting with price. Price is the most important attribute of the all. We have mileage, kilometer per liter. So it's like we wanted to see how fuel efficiency, your label and mileage. So to document the impact of the 2, we even included an interaction term, which I'll show in the results part. Then we included engine, transmission, and the last attribute, which was for the network effect, social network. So one way where we captured the intrinsic motivation was through Likert scale questions. Second way in which we captured the social network was as an attribute. So the social network is measured by the market share of friends, family, neighbors, colleagues. So how much of your friends, family, neighbor, colleagues are buying these energy efficient cars, fuel efficient cars. So say 20% of your friends or neighbors are buying, or 60% are buying. So how will that influence your choices? So for each of these, the levels are stated. So starting with the price. So price you could document as an absolute number also, like it was done in ma'am's paper, ranging from rupees 15 to rupees 300 for the fruit rice crop varieties. But we did another novelty, that we tried to include price as a percentage rather than including it as an absolute number. So for including price, we asked the respondents, okay, at what price are you willing to purchase a car in near future? So each respondent had stated in the questionnaire the price at which they are willing to buy a car in near future. That price, we call it as a reference price. So we asked respondents, are you willing to pay 10% higher than your reference price? Are you willing to pay 20%, 30% higher than your reference price, 40 or even say 50% higher than your reference price? So we ranged prices from 10% to 15% of the price which you are willing to buy in near future, say in next 1 to 2 years. So that was the first attribute with 5 different levels. Second attribute which we included in our study is mileage, measured in terms of kilometer per liter. So for each of the 3 alternatives which we have, high star, moderate star and unlabeled cars, we kept a different mileage level. So for high star labeled car, the mileage was being kept at 20 or 24 kilometer per liter. For moderate star labeled car, the mileage was being kept at 16 and 20 kilometer per liter. And unlabeled, we kept it at 13 kilometer per liter. So interesting twist which we added to this choice experiment was, we wanted to see, say if they have same mileage at 20 level for high star labeled and moderate star, then which one are they willing to buy? Do they consider labels? So we kind of created like a discontinuity in the design by having same levels for the high star and the moderate star label mileage. Mileage for high star and moderate star, same level of 20. Then engine power, the size of the internal engine, which is in Delhi generally varying from up to 1000 cc to 1000 to 1500 cc. And then more than 1500 cc. Then we have included transmission. The levels for transmission, we take it as manual, automatic. And last was your social network. So it's the peer pressure, how is that impacting your choices? So market share among friends, family, neighbors, colleagues. So we fixed it at 20 and 60%. So 20% if of your friends are buying, then you consider buying, or say 60%, as high as 60%. So these were the attributes which we included in our 5 attributes which we included in our study and their levels. Then after deciding this attributes and the levels, the next step was to create choice sets. So as ma'am mentioned, if we could go with a full factorial design, but if we go with the full factorial design, so it will be, let's say, 5 into 3 into 3 to 2, so close to 480 choice sets. So with the full factorial design, it is virtually not possible for any respondent to answer 480 choice sets. So instead of following the full factorial design, we followed the fractional factorial designs. So we calculated the D efficiency. So without much losing on the efficiency, we designed and reduced the number of the choice sets because we did not wanted to compromise on the efficiency part. So we calculated the D efficiency. So it's like minimizing the variance of the regression coefficients, the D efficiency. So with the efficiency which we achieved was 93% efficiency, we had to design at least 19 choice sets. So taking that at least 19, we get ahead and we decided to choose 21 choice sets. So total choice sets we had taken as 21 choice sets. For each respondent, I had given 7 choice sets for each respondent. So rather than giving again 21 choice sets to one respondent, it was too many. So rather than giving 21 choice sets to one, I divided these choice sets into blocks. So as Adan had already discussed, we divided into blocks. So I divided into 3 blocks and 7 choice sets. So that makes it a total of 21 choice sets for 7 choice sets per respondent. So this is one sample of 1 choice sets out of the 21 choice sets which we had created. So it's like respondent has to choose. So in each of these choice sets, respondent has to mark. So it has a high star labeled car with these bunch of the attributes. So attributes like say it is 40% higher, mileage is 20, engine is up to 1000 in this, automatic 60% of my network are buying these cars. So based on that, you choose one alternative. So either high star, moderate star, or you don't want to pay anything higher and you go with the status quo alternative. So this is one possible choice set. So you can observe here we are getting market share as 60-60. So that is possible. All the different combinations are being created. So in some choice sets you might have 20% and 60%. Some choice sets 60-60. Some choices 20%, 20%. So a different combination of all the attributes. Making of total of 21 choice cards which we created. So next was the implementation part. So we decided to conduct this survey on South Delhi and East Delhi. So why we chose South Delhi and East Delhi? Because in South Delhi the people were more affluent as compared to the people in East Delhi. So this we tried to capture by measuring the land prices in South Delhi were much higher as compared to the land prices in East Delhi. So we can clearly categorize. I wanted to see two extreme parts of the Delhi. So out of the total 9 districts in Delhi as per census 2011, we choose 2 districts, South Delhi and East Delhi. We did a total sample of 504 respondents. So there were 252 respondents in South Delhi and 252 respondents in East Delhi. Then within South Delhi and East Delhi, I divided them into 3 sub-districts of South Delhi, 3 sub-districts of East Delhi. So I interviewed 84 respondents per sub-district. So making it to a total of 504, 6 sub-districts. So total of 504, 252 East Delhi and 252 South Delhi. We targeted middle to high, upper middle income class families because these were those who will be willing to buy a car. We don't expect a lower class family to buy a car, or chances are higher for a higher and the upper middle class families. So we interviewed those respondents. So here we followed the split sample approach. So like out of 252 respondents of South Delhi, half were given with the incentive treatment and the other half was not informed about the incentive. So half were informed about the regulation. Like if they buy a high star labeled car, they'll be able to drive that car on all the days. So they were informed about that regulation and other half sample was not informed. So a split sample approach which we followed both for South Delhi and East Delhi. So a total of 252 respondents were informed about the regulation and 252 respondents were not informed about the regulation. So before I move to the results, if you have any questions here. Yeah. So we have covered the choice experiment design and the sampling strategy. If you have any questions, we can take. Otherwise, we'll move to the results part. Yes.
How did you come up with this number of 504?
That was, we thought that we should have at least 500 respondents. So based on that, we decided 504. So as to model and have the accurate choices. Anything else? Okay. So these were the results. So these are the tables which is giving the summary of the socio-economic characteristics which we studied. So we included age, gender, and you will see later on how I incorporate these socio-economic characteristics in the willingness to pay estimates as well. So we took age, gender, are they married, household size, household income, which we ranged from less than 5 lakhs to 5 to 15 lakhs, 15 to 25 lakhs, and income of more than 25 lakhs. We had education, are there high school, graduate, postgraduate, or much higher than that? Occupation, are they involved in service, business, or they are not working. So following our split sample, so all my estimates I report for one, which is the not informed sample. So sample where we do not inform about the driving restrictions. And second is the informed sample. So where we are informing that you buy high star labeled car, you can drive on all the dates. So if we compare the two samples, so that was actually very good, that results which came out, that the two samples were almost similar in terms of the attributes. So we did a two-tailed t-test to check the two samples. So what we found out, only in the number of cars owned by the respondents, there was a slight difference, which was a marginal difference of 2.04 t value. So but for all the other attributes and for occupation other, the two samples are similar. So that kind of justifies the split sample approach also, that my two samples are similar across the socio-economic attributes. So 252 respondents not informed, 252 informed. So the average age was around 40 for both the cases. So you can read through this. Second, we tested, are the two samples also similar across the behavioral motivations? So we have given all the Likert scale questions which we have just talked about: intrinsic motivation, extrinsic motivation, social interaction, and environmental knowledge. So this table includes the list of the questions with the values as well. So we have seen for the informed and the not informed sample, again, like say for extrinsic motivation there is a slight difference, but for rest most of the questions the two samples are same. So which again justifies. Yes. Yeah?
Could you please zoom in a little bit from the question?
I'll just... These questions we have already covered.
Your slides, you can't see it.
I'll try. Is it fine? These tables are actually small. Is it readable now? You can read this first part then. So these are just the intrinsic motivation questions which we had covered. I had already talked about, I feel personally obliged to save energy. While purchasing household items, I take into account how my use will affect the environment. Same questions. So these questions we had separately talked about. Is it now readable? Maybe I can open the paper and show the results table from there. Yeah.
It's okay. I think it's too much of text, so maybe you can.
These are just giving the values. I'll go from there. So that was what was being shown, where these are just giving the mean values for the various behavioral motivations which we have. And the idea was to compare the two samples, like informed and the not informed sample, are they similar or not? So next which we talked about was the So for estimating these results, so we adopted three models: conditional logit model, random parameter logit model, and the latent class logit model. So Sangeeta ma'am has already talked about the conditional logit and the random parameter logit. So that's why I did not included them in these slides. So these are just for those who are interested in the little bit equation part. covering it from where ma'am had actually left. So we are aiming to maximize the utility for individual n choosing alternative j. So j stands from 1 to capital J. So this will be my utility function, same as what ma'am had given. But for each conditional and the conditional logic model, it basically assumes homogeneous preferences. So considering that we may not prefer a conditional logic model, we might want to go for a random parameter logic model. So in random parameter logic model, we are allowing the heterogeneous preferences. So we are allowing the preferences to vary. But the random parameter logic model, it allows all the coefficients to vary except the price coefficient. So in random parameter logic model, we keep price coefficient as fixed and all the other coefficients are varying and they are following a normal distribution. So these conditional and random parameter are already covered, so I'll not go into detail. I'll go more into detail of the latent class logic model, which was not covered. So in random parameter logic model, it's a latent class is a part of a random parameter logic model. But what we do here is we are assigning it into various segments or the various groups. So each individual is characterized into different groups. So it's like the utility of the individual will be same within that class, but the utility will be differing across groups. So it's like, say, you can classify into 5 classes or 5 groups. So within a group, all the individuals have more or less same preferences. So that's the idea of this. So if you say have like an endless number of the classes, endless classes are there, then the random parameter logic model will be converging to a latent class logic model. So we incorporated these conditional logic, random parameter and latent class logic models where we identified the number of the groups. So I'll be talking about how we identify these groups. So in terms of the equations, the first part, so like in MAM, it was the probability of individual n choosing alternative j. So same this probability equation which MAM had talked about, it's the same equation. But here there is another variation is probability of individual n choosing alternative j which is belonging to class G. So for which class you are belonging, based on that, what is the probability? So these probabilities will be estimating it through stata. So that is the first. And the second part is if we are allocating each individual to G number of classes. So how we allocate the individual to different classes. So based on the socio-economic or environmental characteristics which we follow in this, you are allocating each individual to different classes. So the probability of an individual n belonging to class G. So this is the second. So the final unconditional choice probability of individual n choosing alternative j will be the product of the two. So here x is the, ma'am had already talked about, it is the vector of the attributes. Beta is the weight assigned to that attribute. Alpha is the parameter vector for class G, and Z is your socio-economic characteristic like say age, gender, income, different equations which is you are classifying it into the group. So your unconditional choice probabilities will be the product of the two. So any questions you have before I go into the results? Yes.
You mentioned that you had taken middle class and upper middle class and upper class as your sample. But you also mentioned that your income categories were up less than 5 lakh, 5 to 10 lakh, and if I'm not wrong, above 25 lakhs, right?
Yeah.
So I was not able to understand that how, would your middle class and higher income class would fit into the annual income of 5 lakh and...
We basically interviewed the respondents who are located in good localities of Delhi. So like say Kalkaji Defense Colony. So that's how we picked up the different districts.
But I think maybe I'll just rephrase the question. What I meant was that, how would a person earning, let's say, 5 lakh come under the middle class category? Because I think you are grouping it on the basis of income. And you mentioned 5 lakh also as your maybe the first this thing. So I was not able to figure out that, if a person is a middle class person, how would, he be able to come under the annual income of less than 5 lakh?
Yeah, that we did not specifically did the distinction. Yeah.
I could say in that respect is sometimes, so we know they are middle income class, if I understand correctly, because of the neighbors where they live, that we could with certainty say that they are thought as being as middle income class. Usually when we ask people to report income, it's okay to go kind of down in the scale, even if it looks a little bit unrealistic, because people tend to underreport income a lot. So in that respect is that even if they underreport income, the fact that they live in those neighborhoods kind of reveals that they are middle income class people by living there. And as I understand, we went to knock at their doors, right? We were knocking at houses. So, well, not we, right? Clearly, it wasn't me. It was Charu. But that's how we know they were middle income people, because they were living there. But the income, that is a big problem when you ask people to report their self-report income. Yeah.
Any other question? Yeah.
Ma'am, I have two questions. First is, in that model I have seen weights for the attributes in the later slide.
Which?
We'll go to later slide.
Okay.
That's a very interesting part of the paper.
Yeah.
Another question is, because I am seeing you are taking two different groups, groups like one is informed and another is not informed. So, like, can we use a propensity score matching for matching the individuals? Because you have a quite large sample size also. So it will be more realistic to compare than those two peoples. Like somebody is in a higher income group, like not in just higher income, maybe all different parameters when we do a propensity score matching. And then we can compare them both based on their status, based on their score.
Yes.
Can we do that?
I like that question. I like that question because I have thought about it in the context of latent class models. So the easy way to implement your idea is what we are doing, which is basically we are going to run the regressions, and basically we are going to say whether average preferences are different or not, just as they are, by doing this that has no weights, that has no propensity score. And so far, we are following protocol, right? Which is usually the common answer. But I have thought about the fact that by having this type of a split sample, that in this case might not be needed, but in some cases the split samples don't come out very nicely. Here, this work was, the reviewer said it was very good, and we are really happy that the reviewer pointed it out, because as you saw in this and in the other one, with the exception of a very few variables, they are very similar. But what will happen if a split samples where in some cases they are not that similar? I have thought what you are saying. Should we carry out comparisons where we do the propensity score? We say, well, look, in this sample, and this sample, these are the people that look more similar, And when we do the comparisons, we are going to weight more those that are more similar and weight a lot less those that are not similar. That should be possible, right? It's a probit, and we run the logic. We run the probit, we assign weights, and we carry out that. Okay, I think that he's proposing kind of a methodological advancement because I have not seen people doing it. That will be a way to control a posteriori for similarities. So good point. Kudos. And the other thing I want you to understand and think about when Charu starts explaining the results of the latent class models is that somehow latent class models is a method that identifies differences in preferences conditional on being kind of similar within groups in the observables. Implicitly, what the model behind the scenes does is it groups people and says, these people kind of look similar, this group and this group, and it's funny because they react differently. That's the basic logic. The EM algorithm that is behind these methods, EM for expected maximization is the name of the algorithm. The first time I wrote it, it took me like 2 months because it was so easy to start and it was so unintuitive that it was going to start so easy. But basically it starts by randomly, just arbitrarily assigning people to one group and to the other group and start comparing preferences. And then it converges when the groups are similar, but they are very different in preferences. Very similar as similar as possible in observables, and very different in preference as possible. That's the basic idea. And I wanted to relate that to your question. In many respects, it's a propensity score. Because the idea is, how can I find people that are very similar in observables, but that they behave differently? So the latent class is another type of propensity score, but that conversation hasn't happened. There is no, I haven't seen papers describing the latent class models as a type of propensity score. So there we have another methodological conversation.
Sir, I have one more question. Or maybe I just want a clarification regarding this. For propensity score matching, is it not the same sample that we consider and then we give them a treat? Then let's say we give them any for the same sample, firstly, let's say they are not, let's say tested upon some policy matter. And then, for the same sample, when we give them the policy and we try to figure out how, what is the difference in terms of the treat. So in her case, she has clearly mentioned that, there's one sample where she has actually informed them about the incentives. And for the other sample, she has not informed them about the incentives. So I'm not sure if we can use the propensity score matching here, because it's not like that, earlier they were not given the incentive and, suddenly they have been given the incentive. And to figure out the difference between the same sample over, incentive versus non-incentive. So, correct me if I'm wrong.
Yeah, no, in this case, the treatment, what happens in this case is that we don't have the before and after. Yeah. That's the part where it becomes a little bit messy. Yes, you are right in that respect. We are very used to use propensity score matching with a before and after idea. Yes. But in this case, even when there is no before and after, you can always say, well, what was the probability that I randomly, not too well, assign people into the information sample versus not. And basically you try to put in both, try to pick those that are the most similar in observables in both groups. Because what is going to happen what is going to happen is that if these don't look too similar, that means that if you run a regression assigning to the information sample, you are going to obtain positive coefficients in these observables. With these coefficients, then you can pick a sample that makes it as similar as possible to the other one, so that those coefficients are not similar. Does that make sense? Let me repeat it because I realized I didn't explain it well. In this case, the split sample idea, instead of thinking on the split sample idea as the probit, think it in this following way. You are comparing two samples that are not too similar, and you say, oof, I didn't do too well my split sampling. Now, imagine the following. You pick up a random subsample from each category, compare them, or run a probit where the probit, the dependent variable is 1 if I assign you to the sample 1 versus 0. If the coefficients don't come significant, or if this becomes more similar, then it's as if you were doing a propensity score, because those subsamples that you pick randomly are more similar now than the initial samples. Does that make sense? Did that make more sense? It's similar to a split.
I get that. So maybe we can.
Yeah, we can continue? Okay, sorry. Oh, no. Yeah.
Yeah. So we'll continue. So we have talked about the conditional and the latent class logit model. So now I'll be going to the results part. So these data codes, we'll be running them afterwards in a separate session, maybe in tutorial, because we will not be left with time. So where we'll talk about these. So we had done 3 models which we had run. One was the conditional logit model. So the code which we generally use for a conditional logit model is the dependent variable. So in our case, the dependent variable is the choice variable, which is taking values 0 or 1. So like which alternative you are choosing, high star, moderate star, or an unlabeled. And then you can have a set of the independent variables, which will be like all your attributes. So we even include high star, moderate star as one of the attributes, price, mileage, engine, transmission, network. So a set of the attributes, and then the group, each respondent is being assigned a group. So these we can try them separately in Stata. So these were the results which we reported for the conditional logit model. So the conditional logit model is a restrictive model because we assume homogeneous preferences. So it's not much preferred. So we reported them in the appendix. We more focused on the random parameter logit and the latent class logit model. So I'll skip them and I'll more now go to the latent class part. So overall, if we see, we report them for the not informed sample and for the informed sample. Then we do the another addition which we add is interaction and the not interaction term. So we want to see how your high star label and the mileage, because it's like has to be a collinearity between the two. If mileage is increasing, should be that your label is better. So we kind of include an interaction term between the two to see how high star and mileage interaction changes my results. So I'll focus on the interpretation of the random parameter logit model. So same way this is the Stata code for the random parameter logit model. So where the code is mixed logit, dependent variable which will be your choice, independent variables the set of all the attributes. So in random parameter logit model we have heterogeneous preferences. So we assume all the parameters to vary except price. So price is kept as fixed. So I'm defining the random variables, which is your alternative 1 stands for high star labeled, alternative 2 stands for moderate star label, your mileage, engine, transmission and network. And price is kept as separate. And then we are grouping each respondents into the groups. So these are the results of the random parameter logit model. So what we see here is, some beautiful results which we get out is, one is the price coefficient. You can say it is similar at 0.006 for all the cases, for not informed as well as for the informed sample, as well as for no interaction and the interaction cases. All the Other coefficients, my high star label, moderate star, mileage, engine. So these other coefficients are also significant and they are more or less in line with the expectation. So it's like, say, if engine increases, it's more than 1000 cc engine, say your utility is increasing. So for price, we have a negative coefficient which is expected because as price increases, your utility will be falling. So then all these coefficients are positive and statistically significant. One interesting result which we see out here is the network coefficient. So we see the network coefficient in the informed sample. So you can see here. We can get a pointer. Yeah. So here you can see it is 0.0032. So this is insignificant for the informed sample in both no interaction and interaction. So that means when driving restrictions comes into play, the peer pressure network effect is not that important. What is more important impacting is your regulation. But in the case of the informed sample, it is significant, the network coefficient. So rest all the coefficients are significant.
You can also talk about difference in the high star label coefficient.
Yeah. So in high star, I was thinking to talk in willingness to pay. We can cover here also. Because willingness to pay will better give them more relatable results. So then we calculated the willingness to pay estimates. So these are like the betas which ma'am had also talked about. So beta coefficient of the high star label divided by the beta coefficient of the price. So beta coefficient of the moderate star label divided by the beta coefficient of the price. So through that we calculate the willingness to pay, which is being again done for the not informed and the informed sample. Then we do a two-tailed t-test. So we want to see, like, is regulation changing my preferences for all these attributes. So we see in terms of the coefficient for high star label for a no interaction. We have a willingness to pay of 4.936 thousand USD. So we converted all the prices into 1000 USD values. So it is 4.936 for a high star label, which is much higher than the moderate star labeled car. So we can clearly see that people have preferences for a high star labeled car. Next, if we compare it for the not informed sample, it is 4.936. And for the informed sample under no interaction, it is 7.481. So that is how the willingness to pay for a labeled car is increasing when you buy a high star labeled car with the regulation. So like when you have driving restrictions, so like with high star label, there is no driving restrictions. So you are willing to pay more from 4.936 to 7.481. So the difference between these two willingness to pay is close to, I think, 2.55 thousand USD. So this is the cost of the regulation. So if you are imposing a driving restrictions and where there is no driving restrictions on high star, but for others, your cost of regulation is 2.55 thousand USD. So this might seem a high number, but if we compare it with the previous literature, so there is a study by Blackman which did this study for Mexico, Mexican Hono Circular Scheme, and there it had estimated the regulatory cost as 2.96 thousand USD. So it's almost similar to what we are finding it in the literature. Then you can see, so that's the one result which we found out, the cost of the regulation. Then we conducted a p-value test. So you can see if we take it for a no interaction case, the p-value is 0.31. So it is statistically significant. So you can see when we are informing the sample about the regulation, their willingness to pay is increasing for a high star label and it is significant for a high star. both for a no interaction as well as for the interaction. But if you compare it with all the other attributes, it is not significant. Because so these results are in line with what we expect, that for a high star label, regulation is playing a role, which is not playing a role for the other variables. Then you can clearly see the willingness to pay. Let's say take this 200. So for a high star label, it is 6,000 USD. For a not informed sample under interactions, it increases to 13.46 thousand USD for an informed sample under interactions. And its p-value is 0.04, so the results are significant. Next, we see the mileage. So people are willing to pay 0.2 thousand USD for a mileage under interaction, not informed sample interactions. It increases to 0.55 for the informed sample under the interactions. So with this you can interpret. So if there is an increase in 1 kilometer per liter, it decreases the willingness to pay for the best efficiency label equivalent to 350,000 USD. So that's how this willingness to pay we are calculating. So this was what we did for a random parameter logit model. Then like ma'am had talked about the demand curves. So another beautiful thing which we incorporated in this is we estimated the demand curves. So these demand curves, we estimated it for two scenarios. Similarly, like not informed sample and the informed sample. So for the first, these demand curves, we did it for two alternatives, high star labeled car and the moderate star labeled cars. So like all the demand curves are downward sloping, we founded our demand curves downward sloping. But one interesting result which came out. So here we assumed mileage as 20 km per liter, engine as 1000 to 1500 cc, manual transmission and 20% network. So taking these parameters, we formulated the demand curve. So the one with the blue dots is showing the no driving restrictions, with the orange dot is showing the driving restrictions. So you can clearly see that my demand curve is shifting towards right for the high star labeled car. But if we see it for a moderate star labeled car, the demand curves are almost converging. They are almost the same. So this clearly indicates when you have a driving restrictions in place, when you are informing the sample, your demand curve is shifting towards right. So that is another result which we found out. I think I'll cover and then take questions in the end because we are left with a lot of topics.
At least
Latent class. Theta we can do it separately, but I want to cover the latent class. So next is, we estimated the third model which we estimated was latent class logit model. So under the latent class logit model, like we all know, random parameter logit model converges to the latent class logit model for endless number of the classes. So my first task was to identify the number of classes. So I took the classes starting from 2 class to 6 class because 6 was also a reasonably high number. So from 2 to 6 classes, we estimated the information parameters. So we estimated AIC, Ekai information criteria, and BIC, Bayesian information criteria, to see how many number of the classes we want to decide. So that we did it for no interactions and the interactions case, for the not informed and the informed sample. So based on BIC criteria, if you see for an interaction case, the BIC is increasing from 3 to 4 classes. Similarly, it is increasing, a very high increase for informed sample from 2520 to 2557. So clearly you can see when we move from third class to fourth class, at least for the interaction cases, the BIC values are increasing. So taking that into consideration, we decided to choose optimal number of classes as 3. So after deciding these optimal number of the classes, I started to classify the respondents into different classes. So to classify the respondents into different classes, I considered the socio-economic characteristics and the environmental attributes. So the socio-economic characteristics which I included to classify the respondents were age, income, gender, education. So these were the four most important socio-economic characteristics in which we can classify the respondents. So age, like we took it less than 30 years, 30 to 50 or more than 50. So these how we classified the respondents into age. Income, it's already classified less than 5 lakhs, 5 to 15, 15 to 25, more than 25. Education, again high school, graduate, postgraduate. Then second which we included was the environmental factors. So I took all the Likert scale questions which we had talked about: intrinsic motivation, extrinsic motivation, social interaction and environmental knowledge. So taking both socio-economic questions as well as the environmental knowledge, I classified the respondents into different classes. So we classified into 3 classes, and then based on their attributes, we also assigned a label to those classes. So we assigned these 3 labels: intrinsically motivated adopters, extrinsically motivated adopters and non-adopters. So these are my 3 classes. Class 1 is IMA, class 2 is intrinsically motivated, EMA and non-adopters. So the class 1, which is intrinsically motivated adopters, they were like older age group, more than 50 years of age, those who have higher income, they were more educated, they were male, and they had high on all the environmental attributes. So high intrinsic motivation with environmental knowledge, high social network, high in social interactions. Second was the extrinsically motivated class. So these were those class where we documented the peer pressure effect, where their friends and neighbors were more influencing this class. So we named them as intrinsically motivated class. They included middle-aged, middle-income people, educated, both males and females were there. They were average in intrinsic motivation and environmental knowledge, but they scored very high in social network effect. In intrinsic motivation, they were ranked the highest. And last were the non-adopters who were not willing to pay a very high amount. They considered young age, low income individuals, more of the females, and who were scored low on all the behavioral motivation scores. Then these are the percentage values given for each sample. So IMA consisted of 30 to 36%, 40 to 52% range is for EMAs, and non-adopters is a comparatively lower range ranging from 18 to 24%. So these were the logit model codes which are there, same like we have in conditional logit. So LC logit, dependent variable, independent variable, group and ID name. Then you have to specify the number of classes. Here I've chosen 3 classes. Then in membership variable list, you will add all the socio-economic variables which you want to include. So example could be age, gender, income, education, so that you can include it in the membership on the basis of which you are classifying different classes. So these were the results which we got. So these are the results for the not informed sample. So here we have reported separate results for not informed and informed sample by 3 classes: intrinsically motivated, extrinsically motivated class and non-adopters. And again we did a separate for no interaction and the interaction case. We'll just talk about these. Similarly, we do it for the informed sample. So if you see, the willingness to pay is much higher for intrinsically motivated adopters. On a non-informed sample, it is 3.788 thousand USD for a high star labeled car. Under interaction term, the willingness to pay is 5.23 thousand USD. If we compare this willingness to pay for a high informed sample, this willingness to pay is increasing significantly for a high star labeled car. So which is 4.961 for a no interaction and 8.634 for a intrinsically motivated adopters. So one is the intrinsically motivated adopters are willing to pay most for the high star labeled car. Their willingness to pay is the highest. So IMA report the highest for the best efficiency label and mileage. And it is the only group where interactive term is more significant. Whereas for extrinsically motivated adopters, the willingness to pay is second highest for the best efficiency label in the informed sample, but they report a significant willingness to pay for mileage in not informed sample. So if we see the results for EMA, it is the only group where peer pressure effect is most important. So here network is important for a extrinsically motivated class. So these are comparing the willingness to pay for the not informed sample and the informed sample in terms of the three classes. So you can clearly see the willingness to pay is higher for intrinsically motivated, 31.44 thousand USD compared to EMAs, which is 2. For non-adopters, this willingness to pay was insignificant. If we see it for the informed sample, it is very high, 57.98 USD, 1000 USD. So what we see is, okay, first before I'll just show you, we even calculated the average values for the each class. So what is the average value for each class for the different parameters? So for intrinsically motivated, extrinsic, social interaction and environmental knowledge, we calculated their average mean values. So you can, from here we basically, by calculating the average mean values, we try to classify them into 3 classes. So it is 0.69 is the intrinsic motivation, which is highest in IMA. Extrinsic motivation is also very high, 0.69. Their social interaction is high. Environmental knowledge wise also they are high. So this indicates that this class is more concerned towards the environment. Whereas if you see here, within this class, for this class, intrinsic motivation plays one of the important role for a not informed sample. So that is what we found out. So if you have to give the conclusion part, I can say that the car drivers are willing to pay more for the fuel efficient label cars, and their willingness to pay is much higher for a high star label car. So this willingness to pay goes beyond the fuel savings. So we even estimated the fuel savings which could be expected if you are buying a high star labeled car, assuming that say you are driving 12,000 kilometers in a year with a average mileage of 21 kilometer per liter. So this willingness to pay, we found out, was much higher than the willingness to pay arising from the savings due to fuel efficiency. They attach a willingness to pay of 6,000 USD to the efficiency label, which is 30% of the price of the car respondents would be willing to buy. Label is working the most for the extrinsic motivation class, because that class is willing to pay the most. And for extrinsically motivated class, which is representing around 52% of the sample, 40 to 52% of the sample, here the peer effect plays an important role. So basically we found out the policy implication is that these regulations could actually increase the willingness to pay. So with that I'll conclude and we can now take questions. Yes.
Is there an online? We'll take an online also. first half.
Ma'am, I had one question regarding the methodology. This is very new to me. So when you are you dividing your results into basically the you have not made them aware about the policy and the other one. Can't we use it as a variable in the controls, like 1 if they have been informed and 0 otherwise, or is it the method that doesn't allows us to do that? Similarly, when you are dividing it into different classes, you are calculating it separately, and then you are taking a t-test separately to see if there is any significant difference or not. So is it not possible to do it the other way, or will it have some implications in terms of how we interpret the results?
Adan, would you
Yeah,
want to take questions?
I can participate.
Yeah,
in
maybe
that.
he can take questions.
One of the first question is, why don't we include actually the dummy in the regressions? And that is definitely possible. But in this type of specifications, that will have mean that we have to interact the dummy inform with all the other variables, and then the convergence gets a little bit tricky. And what we lose by doing it in a split sample is standard errors, right? Like if we do it all pool, the standard errors are lower. If we do it separate, the standard errors are larger. So if we are finding differences here even with larger standard errors, that means that when we pull it, we will find them anyway. And the other question is, and that is something we will discuss in the next session. When you do what we did here to allocate in different groups, once the latent class tells you there is 2 groups, and then compare as we did, we also should be controlling for standard errors, because it's a little bit of an instrumental variable approach. We didn't do it, but we should be doing some sort of penalizing the standard errors for imputing you into a class. But that is something that we should discuss a little bit in the next session. Yeah.
Online question? Do you want to add something, or
No, we can always add it in the next
next
part of
session.
the
Okay,
session. Thank you so much, Sharu.
Thank you.
Thank you, everyone.
So we break for lunch. Lunch is served outside, and at 1:45 we'll also have a group picture.
Oh, cool.
So everybody should be there. Yeah. Okay. So you can just break.
I truly like to do it this way, because I feel that people get questions or get gaps. Like, how do they do that? What are they talking about? Like, Janelle, in my case, I never learn in a cumulative way. I usually learn things, and then I have a big gap in the middle. Then I went back and fill the gap, and that's how I kind of also like to present. And I think that the cases in the morning probably open a lot of questions. Some of them have to do with how do you estimate latent class models, or what do they mean. And so I think that we can start with a good 5 to 10 minute session of questions that you think that you might have left from the previous session. And then from there, I will try to use them to motivate what we are going to be doing now, which is I'm going to start with kind of going into the data sets, the regressions, illustrate what is heterogeneity in preferences, and so on. And then by the end of the session, we are going to be talking a little bit about your cases. But the good news is that tomorrow is going to be mostly about your cases. Some of you already have shown me very good designs, and I am very happy. So tomorrow, come ready with your table describing the attributes, the labels, and an example with a choice set, right? Ideally, you want to come also with a good title of your paper or your research, right? Like why, that summarizes why it's interesting. So that is going to be mostly tomorrow, but today probably it's a good idea to go into how will you run regressions, how will you see your data when you collect the data, blah, blah, blah. Any questions before we go into that, so that I use them as excuse? Yes.
So I wanted to know how we do the groupings in random parameter logic. How do we do it? Is it similar to how we do it in PSM, like giving probabilities of being in a specific group? Okay.
No, that's a very good question because that is going to give me the excuse actually. Very good. Okay, so you guys, I think you guys are ready to start seeing coding. I just feel that then that's when going through this kind of through the code is going to make sense for some of you. Maybe for some others it will make less sense, but let's see. So what you are seeing here is a data set that already looks as a discrete choice data set or as a choice set with the format that you will need in order to run your regressions in this data. Before I explain it to you, I just want to tell you, usually what you are going to have, imagine that you have 504 respondents. Then you are going to have, you are going to have 504 rows in your data set, right? Most of you, I imagine, have run regressions. And you can imagine that if you have 500 respondents, you are going to see 500 rows, right? Where every row is a respondent ID, right? ID from 1 to 504. And every column is going to be a variable that reflects the respondent's answers to some of your questions, right? Okay, so pay attention to what I have here. ID is the ID for a respondent, as usual. Then, for the time being, don't pay attention to the W. Pay attention to the block, to the set, to the group, to the alt, that means alternative. Choice, which means what you pick. Green, parking, facade, lane, status quo variable. Maybe by now you know which data set this is about that discrete choice experiment I keep bringing and bringing and bringing, right? More or less, most of you have an intuition. Okay, why? First question, why do I have so many ones there at the beginning, reflecting the ID? Can you repeat that? Okay, how many times should I be having repeated that one? Number of choices, okay, times. No. No. It has to be times the choices. Okay? And every row reflects actually the choice of every individual when facing the specific alternative. So again, stay with me. This is the part that I think that can be boring or it can be illuminating depending on where we are, each of us. So let's read the line. When I was a college student, honestly, this is what helped me. So I hope that it helps you. Some of you might be faster and then it might bore you, but I was kind of slowish. Individual 1, you probably can guess that this individual received choice sets in the block 1. By now, I expect that you have a little bit of intuition what this block variable means. Remember, when we design the choice sets, we say but we are going to put those choice sets within blocks, and I'm going to assign people randomly to the blocks. So, you know, as you can see here, people in ID1 and ID2, both of them were facing choice sets in the block 1. Now, the first choice set that this individual faced was the choice set 3, as you can see here. And then by the fact that this is repeating 3 times, you probably can guess there is alternative 1, 2, and 3 in every choice set. Because look, Then I have 1, 2, 3 for choice set 4, 4, 4. Choice set 5, 5, 5. 1, 2, 3. 1, 2, 3. 9, 9, 9. So this is for you to know, for instance, that once you design the sets, there are not going to be 1, 2, 3, 4, 5 for group for block 1, 2, 3, 4. Because you allocate them randomly, of course, they don't follow a logical order. Okay, I'm going to explain later on what is group. But please help me, tell me what this variable choice is telling you so far. If you only consider the variable alternative and set an ID. What do we know here?
Whether they want green or not.
Can you repeat that?
Whether they want green or not.
Don't go to the other variables yet. Just think, if I am reading up to here, the first 3 lines up to here, the first 3 rows, if you consider the variable alternative, the variable set, the variable ID, what does it mean?
They're choosing the first alternative.
That's what it means. It means that they are choosing the first alternative, no? That's all we know up to there. We know that individual 1, when faced to choice set 3, chooses alternative 1, because that's what this variable says, choice 1, alternative 1, and does not choose automatically alternative 2 and alternative 3. If we go to the next one, they chose alternative 2, no? And we are still talking about individual 1, but if we went here for individual 2, we will be talking alternative 2 in choice set 7, right? Does it make sense? Okay, and now we go to where you wanted to go. Yes, question? No? What does it mean that this person chooses alternative 1? So right now we know that it chooses alternative 1. Now please read green, parking, facade, and lane. Please, some of you raise your hand and interpret what that alternative is, or what it means choosing alternative 1 in terms of the attributes. What is this person choosing? This 0.3 you can interpret it as 30%. I think this is 30% as well. Facade 20%. And lane you can imagine that is no. Right? So this person is preferring to have 30% green, giving up 30% of parking, giving up 20% of facade, and not giving up lanes, against having 40%, giving up 10% of parking, 50% of facade and lane. That, for instance, the reason why I go that slow at this stage is because, for instance, remember how I told you at the very beginning that these respondents surprised me because they didn't want to give up facade. Well, that's what they are saying here. Look, when presented to giving up 50% of the facade, they prefer to give up 30% of the parking. That's what it says here. Why do I have the alternative 3, 0, 0, 0, 0, 0? And then if you go and look for every alternative, it's 3, 0, 0, 0, 0. The alternative 3 is the status quo. For purpose of coding, it is 0 because when it comes to the computations, this model estimates differences in utility, making the status quo, in this case, unit. It makes it the baseline. So automatically every single coefficient that you interpret coming out from the regression is with reference to the status quo, unless otherwise. With reference to the status quo levels, with respect to the levels of the status quo.
Did we talk
Yes.
What is block, set,
Uh-huh.
and all?
Who tells me what is block? Someone help us answer that question. Who knows what is block?
Is it that you were mentioning that you divide those choice sets into blocks, and then in those blocks you present certain choice sets, and in other blocks you present certain different choice sets?
Exactly. Randomly. So when you design the discrete choice experiment, you design it by blocks because you don't want to present everyone to all the choice sets. So if you have, for instance, 100 choice sets, you divide it in 10 blocks, and therefore you have 10 choice sets in each block that you allocate randomly. And then those blocks, you allocate people randomly to those blocks. So in this example, people, the first person and the second person are in block 1. I am about to go down, and you will see that other people, other respondent, is in block 2, likely. I think so. So that is a good question. And the group, I am about to explain that one. Of course. Questions in the questions online?
There are.
While I remember my question. There.
Are there?
No questions online? Okay. Very good. So that is block. Block is the block of the block in which the choice set falls. Let me go down so that you see. I never know how to do the font, the font in here bigger. Anyone knows how to do it fast? So that you guys can see it back there better. If you cannot see it in my screen.
Why don't you come this side, right? Can you see, Karen? No, because when I was sitting there, I couldn't, but I can see very clearly from here.
If you want to move to the front, that will be good.
To the front, because we're doing a lot of, learning as to how actually.
In the view section.
View. Then.
Have, maybe property.
I have tried several times.
Ma'am, right click will go.
Right click in the middle.
No, sir, in the data set.
Here.
Font.
Last one. Font.
Aha.
There we can.
Woohoo.
You have a smart class.
Font. There. Much better, no? Okay. Also, I was going to say, if you need to do it, you can also access already this in the Google Drive. Okay.
Yeah,
Okay.
it's there, but you can learn how to
Now.
understand what data looks like.
Yeah. Okay. So I'm going down. Yes.
So I could not understand what are IDs and why are we numbering them as 1 and 2?
The ID reflects the identifier. So it's the respondent. 1, 2, 3, 4, 5. So in this case, I don't remember exactly, but I have 104 respondents. And basically what I wanted to clarify here is that in a regular database, you are going to have as many rows as respondents. But in this case, you have to make sure that you have as many rows as respondents times choice sets times number of alternatives in each choice set. That's why we have it repeated. And then this block, let me go down. You can see now that the respondent number 2 was also assigned to the block 1, but here the respondent number 3 was assigned to the block 2. That's how you know who responded which choice set. Okay? And in some of the questions that the reason why I'm going so into detail is because you already saw some of the regressions that Charu presented. And you will see regressions when you read the papers, I hope. And then one of the questions somewhere, it was like, so what do you do? How do you do the regression? What does the parameter reflect? How do you enter the variables? Because what you see, of course, in the screen when you see the discrete choice experiment, the choice set is the figure or the illustration or the lab values, right? But this is how we enter. So you describe the choice, the alternatives, as they look in the figure, but in numbers, right? So with the design that I presented to you several times already, you can guess that what I was presenting on the very top of my choice sets when it was green, for the alternative one there, was 30% of extra green. Let me go to facade. I am presenting 20%. And I am saying, well, in alternative one, there will not be reduction of lane. But then, for purposes of my regression, remember that I was presented in the discrete choice experiment number of parking spots that you give up. In this case, what I did, instead of making it number, I decided I was going to be working only with percentages in all the variables. So I went back, and before putting it in format, I said, okay, if there are 3,600 permits, and then the number I was represented 30%, like in this case, I converted all those numbers in percentages. So here I am already presenting to you the numbers in percentages. What will we have done for the case of our paper with Charu and Sangeeta? Remember, we had a reference price, and then we said, will you pay 20%? Will you pay 30%? Instead of presenting percentages here, we could have, but in our regressions, if you go and see, because Charu already put the data set, you are not going to see percentages for the case of price. You are going to see rupees, because we took, when we describe in the data set the price, we multiply the reference price plus the percentage that we presented in every one of the alternatives. So here, of course, what I'm trying to make the point is you have to know what are the units so that you know how to interpret the coefficients. Okay, so that's the data set. What is group? I really like to explain this one because I am not going to lie. I understood why do we need this variable only like 5 years ago, but I have been doing these models like 15 years, so it took me only 10 years to understand why do we need. I did it because you have to do it, and otherwise it doesn't work. Okay, but now I know, and I am very happy to share with you my wisdom. Okay, I'm going to go down and please infer what this group is meaning, because it comes from the combination of something and something that you can see there. So group 1, 1, 1, 2, 2, 2, 3, 3, 3, 4, 4, 4, 5, 5, 5, 6, 6, 6, 7, 7, 7, 8, 8, 8. Do you see the pattern? What is it reflecting? No block, but set and respondent, right? So it takes value 1, 1, 1. It takes value 1, 1, 1 for the first 3 rows, which are for the first individual and the first choice set. Then takes value 2, 2, 2 for the first individual and the second choice set for that individual, and so on and so on until 6, which in this case is how many we presented to them. But then now it takes value 7, 7, 7, 2, 12 for the second individual, and 13 to 18 for the third individual, and so on and so on and so on. This variable is counting the number of choice decisions, the number of someone taking decisions, no matter who. No matter who, right? Like, it's going to be 6 for the first one, then 6 more for the second one. Then what is it? What is it counting? If I am counting the number of decision situations, I am counting how many times we presented someone to the opportunity to take a decision. The reason why we need this variable, and you will see it for the conditional logic model, is because the conditional logic model assumes that these decisions are taken by the same person. That's how it assumes homogeneity. It doesn't distinguish. For the reason why it's going to be counting the number of decision moments is because it needs to know how many times a person took a decision. It doesn't matter who the person is. And that is how you implement econometrically or statistically or in coding the assumption of homogeneity in the conditional logic model. Otherwise, the model will not be able to know that the same person is taking the decision. But that's kind of what I want to emphasize at this stage. So at this stage, please stop me at any moment, because for me is the moment. It has been 4 days. I have been throwing just terminology to you and putting you to read. But now let's start figuring out things. So if you don't understand, stop me. But then the point is, the first model that you estimate on this type of data is called conditional logic, and we have said several times the conditional logic assumes homogeneity in preferences. The way to do it in practice is just to say, well, I'm going to count the number of decisions taken in the data, and I'm going to assume that it was the same person, and I'm going to be doing that regression as such. Yes.
You just mentioned that ID is basically respondents, fine, but you have one for, till 18th, this thing, 18th number. So why is that? So it should be ideally 1 to 18 or something?
Yes, the ID has to reflect how many times the respondent 1 faced a decision in the exercise, and that is times the number of choice sets times the number of alternatives in each choice set. That's why it has 18.
Okay, so he is basically facing choices 18 times.
18 times.
Respondent is okay.
And every other one.
Okay.
Mm-hmm. Yes, there is a question in the... Should I read it?
Yes,
Thanks. How do you use those groups during the analysis? Do you control this in the analysis, say in conditional logic? Exactly. Well, you don't control. Basically, you are counting the number of choice times, and then you say, well, and this is the number of times that the same person took the decision. That is the assumption behind the conditional logic. And I'm going to tell you how we later on relax it in the mixed logic and in the latent class logic. But without this variable, you cannot run a conditional logic, because you cannot assume or you cannot implement in practice the homogeneity in preference. It took me only 10 years to figure it out.
Can you see a little bit more?
Yeah, let me make this a little bit smaller so that you can see more.
Well, that question is, do they represent alternative specific constants also?
Can you repeat the question?
Yes, sir. So, following this question, again, sir is asking, do they represent alternative specific constants?
No. No, we will have later on the possibility to include alternative specific constants with the status quo, for instance. I will show you. Very good question. Let me just go through here. So I should go with group, right? You want to keep seeing group?
I saw. So my only thing was that when we move to second, third, it keeps on increasing because of the assumption of homogeneity.
Exactly. It's like choice number of times that someone makes a choice or faces a choice set. And that someone is the same one.
Yeah, in mixed logic it will be different.
Exactly. So how do I want you to see this? Let me show you. So we said it was like this. Oh, it doesn't work here. Oh yeah, excellent. So you're going to have this do file as well in your Google Drive, but just for safety reasons that you guys don't mess up too much with the data set. We are only going to have this data set. So you are not going to be using the pen thing, right? But the rest of the code should run equally. Okay. So look how here is where I create the grouping. In this case, I call it group 2. The variables, the replacing. Okay. Here. I hope all of you know how to use the local and the global. Here I am defining the local variable as choice, which is my variable choice that you already saw. 1 if you choose the alternative, 0 if you don't choose the alternative. And the attributes, green, parking, facade, and lane. And that is the other thing I want to emphasize here, because these regressions are a little bit different than the regular OLS. I am assuming everyone here has run an ordinary least square regression, or a logit probit, or a logit or a probit. And usually what you do there is the variables that explain the decisions that you model are variables describing the decision maker. But in this type of models, it's very difficult to incorporate the decision maker variables or descriptions or characteristics into the regression itself. What you include is the variables describing the alternatives. Alternative specific characteristics are called. You cannot include directly the respondent specific characteristics. You don't include age, you don't include gender, you don't include nothing. Why? Because of what both Charu and Sangeeta covered today in the morning. These models, when they model your probability of deciding something, they take the difference of the utility that each of the alternatives gives you. But the utility that alternative 1 gives you, minus the utility that alternative 2 gives you, it washes out any kind of characteristics that matter in the utility function. What changes in those utilities is the characteristics of the alternatives, not the characteristics of the respondent. So, one way to interpret these regressions is conditional on your characteristics. What is going to make you more happy? Nothing makes you happier of these alternatives because you are richer. Because that will be the way to interpret it if we were going to include here directly the income, or because you are older. You don't include. Now, this that I am saying, I hope that the big guys in the Discrete experiment don't see the video on YouTube, because they are going to get mad at me. Now, but the truth is, today the practice does not include individual specific or respondent specific characteristics. In the 90s, and still some in the 2000s, late 2000s, when they wanted to include individual specific characteristics, they multiply the characteristics that describe the alternatives times the characteristics that describe the respondent. So they will include, for instance, green times age, parking times age, facade times age, lane times age. And then if you think that income also matters, or education, the same. Green times education, blah, blah, blah. You can imagine the complication, no? I mean, after 3 interactions times 4, it was not fun, and you will see later on that actually with the conditional logic it may work, but when it comes to the mixed logic and the latent class logics, that's when the practice went down. And today there is no book where you are going to find this recommendation. That's why I am risking someone getting mad at me. But my recommendation to you is do not interact or include individual specific characteristics in the regressions explaining the choice decision. Now, if I am recommending you this, why did Charu and Sangeeta and myself, why did we do all those questions about intrinsic motivation, about, and how did we control for age? Well, we will see. But it's not in the first regression. So right now, slowly but surely, I am entering in the estimation process. And the main message I want you to get at this stage is that when it comes to analyzing discrete choice experiments, you have to think on stages. We just reviewed a paper, remember, Sangeeta? Where actually we are asking the author to be the first one going through, I think I said 18 steps. I'm not going to present the 18 steps to you, but definitely at least 5 of them. Because first you have to analyze whether people are reacting or not to the attributes. That's the first thing that you have to convince a reviewer and convince yourself. After all this exercise, after my semi-structured interviews, after my focus groups, after my pilot, and then now I have my 500 answers. Did people react or not to my attributes? That's what you are going to run here. So if you run this line, you are going to have how people reacted to your attributes. I'm not going to run it because I have it ready here for you to see. Let me see, what's the name of the CL mix? Okay. Okay. Don't pay attention to ML. Just there, right? What do you think? Do you know how to read tables with the stars and everything? Everyone? Everyone has run your regressions in Stata, no? Stars means that the variables are statistically significant, or that you can reject the null hypothesis, or that the coefficient is 0. And no stars means that you cannot reject the null hypothesis that the coefficient is 0. So with that piece of information, did I do a good job in my discrete choice experiment with urban green spaces, relocating parking spaces, building green facade, and reducing the road lane? Did I do a good job? Did I? Don't feel afraid. These results will mean that I did a terrible job. Why? Because the people responding my survey are reacting positively. By the way, at this stage, let's only focus on signs, please. If you have run logits and probits, you already know that the parameters coming out, the coefficients coming out of those models are not interpretable in magnitude. You can only interpret the sign, okay? So let's just focus on whether they are positive and significative, negative and significative, or 0. And later on we are going to focus on the marginal radius substitution. Well, this means that people react positively to an increase in green spaces. The 3 stars means that actually the null hypothesis can be rejected at 99% confidence. And the same for reduction in lane, actually. That this one to me was pretty impressive. People prefer reduction in lane over relocating parking spaces or building green facade. And they are very, very happy. Look, well, I don't know if very happy, right? But they are they react statistically significant, with the statistical significance. But then the two things that I want to emphasize in this first initial regression, that is a conditional logic where I am assuming homogeneity in preferences, is that they don't react to relocating parking spaces, and they kind of react to building green facade, but let's focus on the relocating parking spaces. The fact that that number is practically zero, or that cannot be rejected to be zero, it should raise the alarms, among other things, because we already went with the hypothesis that should be very important, no? We were discussing this in the very first class. I told you, well, why will you give up your parking space? And we concluded the parking space, we don't want to give it up in cities like this and Mexico City, and neither in that one. So did I do a bad job? What do you think? So again, just to follow the flow of what I was trying to tell you, you collect your data, you did your work beautifully. The first thing you have to run is a conditional logic. There. And the first thing you want to do is to don't think on how this varies by age, by income, by education. Don't think on that yet. The first question is, do people react positively or negatively to my attributes? The answer here is, thanks God for green space, yes. It's very surprisingly to me for road lane, yes. And super surprisingly for me, they are not reacting to reduction in parking spaces. So there, the first question I asked myself was, did I do something wrong? Did we not do good semi-structured interviews? Did we not do good focus groups? What is wrong? I did not want to believe that people don't react to losing parking spaces. Well, good for us, the good news for us is that there is a little problem with the conditional logic always. The homogeneity in preferences assumption implies that because this model is non-linear, the coefficients are going to be biased if in reality people have heterogeneity in preferences. I am going to repeat that because something that you are forgetting when I say this is, do you know what is the assumption behind an ordinary least square? Do you remember? What is the interpretation? Why do you run an ordinary least square and you obtain a coefficient that you interpret like, as the marginal effects, and then you impute it to the population? Is the average reaction in the population assuming homogeneity, controlling for the observer? Everyone reacts the same to the, if you are running instrumental variable approach and you want to find causality, you say, well, on average, everyone is reacting like this to this. Voila. And no one is going to come and tell you, oh, yeah, but I'm mixing Spanish, sorry. But no one is going to come and tell you, but there are heterogeneity in preferences or heterogeneity in effects. Why are you imputing the average? Because due to linearity of the model, as long as the heterogeneity in the effects have nothing to do with the error, or they are randomly distributed there in the error, the average is as good as it is. There is no biasness in a linear model. That doesn't hold in a non-linear model. These models are non-linear, they are probabilistic. Therefore, heterogeneity in preferences delivers or makes that a model that assumes homogeneity is going to be delivering bias estimates. So, as a first initial round of exercises, conditional logic works perfectly. But it's always going to give you biased results. So the first thing, after getting a little bit worried because I didn't have a positive effect there, Well, I remember, it's bias, so I'm going to run a mixed logit. Okay. How do I run a mixed logit? The coding is here, and it was also presented by Charu here. So before I show you the results, and again you have this in the Google Drive. The first thing I wanna tell you is that a mixed logit is a generalization of the conditional logit that allows that every single one of us have a randomly distributed set of preferences. What does that mean? Instead of assuming that everyone responding these choice sets have the same preferences and the same beta are going to represent us, it goes to the extreme and it assumes that the preferences of person one are so wide, so crazy, so specific that it can come from its own normally distributed set of variables. And the same for you, and the same for you, and the same for every one of us. It is I like to think on the mixed logit as a statistical artifact to fix as much randomness in things that you don't see and you cannot explain by imputing preferences to each of us, so that the distribution of the decisions, the likelihood of the distribution of the decisions gets as pretty as possible. So instead of averaging, it maximizes the likelihood function for you, one, then for you, then for you, then for you, then for you. It maximizes the likelihood function for everyone in the decision making. That's why, in contrast to the conditional logit, now we are adding that ID, the variable ID. The conditional logit didn't need me to tell it who was who. The conditional logit only needed me to tell it there are this group variable that I explained to you. There are this whatever number of decisions. Now I tell, well, look, from decision 1 to 6 is individual 1. From decision 7 to 12 is individual 2. That's what I am telling with the extra ID line variable here. I know that this is the boring part. This is telling the program to do a maximization of the likelihood function by person. Why am I spending time on this? Because go do it in your own time, because Charu and I are not going to do it here because it takes forever. Imagine, right? That's why it takes forever. Because it's going to do as many maximizations of likelihood function as individuals in the sample. This sometimes my wife is my wife knows when I am running regressions while I am on vacation because I am happy. She's like, "Oh, you are too happy. You probably you left the stata running, right?" I'm like, "Yeah, exactly. That's why I'm happier." Because when I am in vacation and the stata is not running, I'm like, I should be running logits. I should be running mixed logits because it takes forever. So the best thing I do is whenever I know I'm going to go for 1 week of vacation, enter and then start running. I feel happy. I'm like, oh yeah, I'm working. So that's a tip for you also. Whenever you need to run these ones, leave enough time because it's not going to be like an OLS or a panel model, or it's going to take forever. And late in class even more. Poor Charu, who had to estimate the ones in hour. Okay, so but that's why I want you to give you an intuition of why. That ID, that extra ID, it's telling the program, run the model for maximize the likelihood function for everyone. each of the respondents, for each of the respondents. Okay? And then redo it because I don't know if you understand simulated likelihood function, but basically what happens is it does it for one, holds the solution for that one, it does it for the second, for the third, blah, 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 holds, and by then it says, how does the likelihood look globally? Can it look better? Yes. And repeats the whole thing, and the whole thing, and the whole thing. So that's what mixed logic does, because it assumes that each of us have our own preference. That's why it's called the mixed logic. That is called the command. I personally like to call them better random parameters logic, because it's more illustrative of what it actually does. It assumes that your parameter is random, my parameter is random, blah, 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 blah. Okay. So I will recommend you to call it random parameter logic for a good while, so that you remember. Now, if you read one of those papers that I put there in the Google Drive by Kenneth Train and McFadden 2000, and you understand it, please send me an email because I want to see you in Zoom, and please explain it to me. But everyone says that what they show in that paper is that these models are so flexible that it literally can adjust any kind of distribution of parameters, any kind of patterns. It's the most flexible model in theory, and the theory is there in that paper. In practice, the models become very untractable very easily. So here is what I recommend you. You should run your models allowing all the attributes to be random and to be random and normal. Random and normal are correlated among them, unless you have a strong reason for one of them to not. And as economists, there is one. That's why Charu didn't run price as random. So if I had a price here, monetary price, I will put here price, which is what you will see with the coding that you will access with that Charu presented to you. Price here, that in the coding mix that they are going to be fixed, and the rest here as random, normally distributed, either uncorrelated or correlated. That's why I recommend. Go for randomly distributed, normally all of them, correlated, not correlated. Unless you have price in the discrete choice experiment, keep it fixed. And the reason to keep it fixed is theoretical from economic perspective. Economic theory crashes if you get utility from an increase in prices. We don't know how to interpret that. There is one section of the universe called luxury goods, where we see an increase in price and then people want to buy more Swarovski, I think are called, or those things, right? Like Lamborghini, I don't know. But with exception, which I think you are not going to be dealing most of what I have seen with luxury goods, if you allow that the price parameter is distributed randomly, you will be allowing for it to take values that will imply that a higher price will bring you more utility. And that is something that we cannot afford as economists, because then we lose our jobs. That's all that we talk about with demand and supply. If we cannot talk of a negative curve of demand, then we are without jobs. So price, keep it fixed, and make all other randomly distributed, uncorrelated or correlated among them, unless you have a good reason to not do that. Okay? Does that make sense? more or less? Okay. So I run those models, okay? Here I don't have prices. That's why I also wanted to show you this one, because I thought it was just easy to do. Now, the first one is the mixed logic, and the other one is the mixed logic with correlation. And I am not going to be discussing both of them. I am going to go and discuss the one that behaves better according to the Akaike information criterion or Bayesian information criterion. Let's see how good you study your econometrics. What are these? Yes? Yeah.
Which model shows the better fit? Which model shows better?
Yeah, it's a measure of.
The better that model predicts.
Is the measure of statistical fitness of the model. Now, I'm going to spend a little bit of time because I personally didn't understand what that meant until 5 years ago, I guess. So, what do we mean by that? What about statistical fitness? It just sounds like, to me, the first time I heard it when I was in my 20s, I was like, it just felt like the model goes for a jogging and comes back and feels better, no? Like, or goes to the gym and is more fit. So statistical fitness means something that is a little bit tautological, because you don't know what is the real distribution behind the data that you collect. You just don't know. If you knew, then you didn't need the statistical model, right? That's the tautology. You assume a model that you want it to replicate parametrically the distribution of your observed decisions. Well, statistical fitness means that you choose the model that better replicates those decisions, that better walks through those decisions in the middle, right? Like in the OLS, the best statistical fitness is the one that passes the best in the middle of all the points, which doesn't mean that it has the best predictive power, right? It depends a lot on the distribution, because you might have all these crazy points and you can get the best fitness in the middle and still prediction, which is the big difference between economics and predictive models. Now that we are in this part of the conversation, machine learning, artificial intelligence, all that is predictive. It's not explanatory. So don't give up on your causality, not yet, in economics. Study your econometrics, because you want to explain. We also want to predict, but we also want to explain. Okay? So that is what it means. Now, here is the thing. The single measure of fitness should be likelihood function, no? The likelihood function is how good you reproduce the observed distribution, which in this case is this one, LL. So here, clearly, the one that has the lowest value is this, no? The best fit. Now, why is that I don't use the likelihood function? Why do I have to use Akaike and Bayesian criteria to decide which one is my best model, statistically speaking? What does the Akaike and the Bayesian do to the likelihood function? It penalizes it. What happens, something that you should remember forever, ever, is the more parameters are in your model, the more you parameterize your model, the better you are going to fit the likelihood function. But then you are going to have a problem of over parameterization, right? Over that. So the likelihood function, just checking that the likelihood function is better fit is not enough. You have to penalize for parameterization, and that is what Akaike and Bayesian does. It tells you, yeah, well, you got better, but you are putting way too many parameters to parameterize this, to fit this. That's why we go and pick the models that behave the best according to AIC and BIC. In this case, of course, as lecturer, we have to pick the easy ones. The reason why I picked this one is because it's very easy to see that in this case, the one that wins is the third one. But Charo, Sangeeta, and other people with this model, with experience with this model, will tell you that the decision doesn't come easy. Sometimes one of them says something and the other says something else, and then you don't know what to pick. But in this case, both the AIC and the BIC says, okay, it seems that your best model is the model that has correlation. Okay? So I'm going to start discussing that one, and I'm going to tell you what it means. So don't pay attention to the one in the middle, which is the one without correlation. What is the first thing that jumps into your face with respect to the conversation we had with respect to the conditional logic? I will hope that you guys are not that sleepy to not see that this one that was getting me worried, it got significant and it remained negative, which was my hypothesis, right? That you will be unhappy of giving up your parking spaces. This one remained positive, significant. That was my hypothesis. This one remained positive, significant. That was my hypothesis. And then all of a sudden, you don't care about facade. So far, so good, no? I mean, this model makes me happier. Which is to emphasize how important is that you go with certain pre-idea of where the direction should go. It makes me happy because I had that pre-idea, which is basically an hypothesis, right? You cannot go and just run the regression and say, oh, well, let's see what it comes out. Okay? Now, this one, I was expecting them to actually be willing to give it up. But it's insignificant. And in the other ones, I saw that it was positive and significant, so I was a little bit worried. But this is where the things become very interesting. Very, very interesting. That is where I want you to go yourself. I should discuss these coefficients at the bottom, all this in the right, but they get a little bit messy. So I want to, just for the time being, assume that we are going to focus on this, and they apply to the last model, because they apply to the last model more or less. What happens when you estimate mixed logit models or random parameter logics is that the coefficients that you see there, these and this, are the average preferences, the average utilities in the sample. But remember that is the average of the averages, because every one of us had their own distribution. So, because we assume that it was normally distributed, it also delivers standard deviations. So so that is the part where you see heterogeneity. In the first model, it only delivered 1 point estimate and nothing else, because we all reacted like that, like in an OLS. In these models where we have random parameter logics, it delivers the average parameter and the estimate of the standard deviation of that parameter, which basically is interpreted as, in average, we get this parameter 139, all of us, but within of us, there is such a distribution of those parameters that is represented by a standard deviation of 2.45. Now, I don't know if you know, but having a standard deviation that is twice as much as your average is bad news in terms of distribution. Do you see it? Like when you have an average of 1, and your standard deviation is 0.1, that means that more or less the distribution goes from 0.1 to 1.9, no? But if you have an average of 1 and a standard deviation of 3, then it goes from minus something to plus something, right? So more or less with that intuition, you should see that not only these coefficients have significant standard deviation, but for instance, the fact that the point estimate, the average is, the fact that the standard deviation is at least twice as much is bad news. That means that it has a lot of heterogeneity in preferences. That is what these models are telling you. They are beautiful models that at once tells you not only there is no homogeneity, but there is a lot of heterogeneity. Sometimes it tells you there is heterogeneity, but it's not that much. And some of the times, actually, some of these coefficients, standard deviation coefficients, don't come significant. Well, let's focus on the facade. What happens is, look, as I said, I should be explaining to you the ones here in the right, okay? But they are a little bit more tricky, but it applies. The facade says in average people don't react, or in average people are indifferent. And this standard deviation means, together with this 0 or a statistical 0, 50% of the people are very unhappy with giving up their facade, and 50% of the people are okay with giving up their facade. That is what these results mean. So something that to me was very, 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 very interesting and very novel is that interpreting these results, the one that turned out to be the most contentious topic was giving up facades. That is what this is telling me. It is so contentious that in average it looks as if people are not reacting to it, as if people are not willing to give up. Basically, those that dislike it, they dislike it as much as those that like it. So just to begin with the policy implications so that you don't fall asleep on me, the very first initial policy implication without doing anything else is, if you are the organization that got in contact with my psychology colleagues and try to convince your neighbors of implementing some policies, some changes in the neighborhood, do not go into giving up green facade. Do not start with that. If you start with, let's plan how we put green our facades, you are going to divide the auditorium in two, the one in favor and the one against. Go with, let's reduce the lane. Because in average, everyone wanted to increase green, and in average, everyone wanted to reduce the lane. And then, once you see how much they are willing to reduce of lane, I will go for relocating parking spaces, because while it is disliked, it is less polemic than this. Do you see it as clearly as I see it? Probably not, right? But that's the intuition. Let me show you one figure. Yeah.
So how do we deduce that 50% wanted it and 50%?
Very good. Thank you so much. Thank you so much, Sangeeta. It's not 50-50. It is not necessarily 50-50, but it's going to be more or less 40-60, 75-35, because it depends on how far it goes in the tail. And that's why you do what I am going to do. You run your model, you interpret it as clearly and beautifully as I have done with the experience of 15 years. Okay. And then you estimate, give me a second, here. Pay attention to this line. For every model that is a mixed logic model, you can ask the model to deliver the individual parameters of everyone, the preferences in the sample. So once you have those estimates, what do you do with those estimates just to figure out? Well, you do this, right? You graph them, you produce the distribution, right? So let me show you. Preferences for facade. That's how they look. Take a look. So right now I don't remember exactly the proportion. I counted. It's around 60-40. But basically the point is, and here actually I am excluding the very tails. I put it from minus 0.005 and plus 0.05 because it goes very far. But basically the point is, more or less, there is the same density in the right than in the left. That is how the preferences for facade are distributed. So that you have a good reference point. Let me show you how the preferences for green are distributed. What do you think there? When they are in the positive side means that they have utility. So a good 80% of the density goes into the utility portion. But these kind of graphs also show that, there is always a 20% of people who were not happy of having green. But in this specific case, the majority goes into the positive side of the preferences. Questions at this point? We haven't talked about latent class analysis, but I want to talk about latent class analysis in a moment, because any time that you see a distribution that looks like this, that is bimodal, suspect latent class, suspect finding mixture models. I will tell you why.
What does it look like for the parking spaces? So won't the majority be on this side?
Oh, you want to see the parking space?
Yeah.
Parking space. Let's see. I think that one also was a little bit, it was less obvious actually, I think. Let's see. Parking space. There. Yeah, no, to the left, no? More or less.
Then why would we prefer this to taking away the green facade?
Because, so here is my point. My point is, in terms of contentiousness, in terms of what is more
Agreeable to everyone.
to like who is kind of in both sides of the equation, the green facade, half of the people, or half of the density, I don't know exactly if half of the people, but more or less half of the density, look, it's to the right and to the left. So if right now I start the conversation with my neighbors and I tell them, let's start getting the facades green, it's clearly that I want to move half of them to the right and half to the left. That's not a very smart way to start the conversation. I will start with road lane, decreasing it, because there most of the people were okay. Then I will go into parking, because even when everyone dislike it, there is not going to be contentiousness. Everyone is going to agree.
But then the policy won't be agreed on, right?
Well, here is the thing. You have a point of negotiation. No? This part, actually, now that I think about it, I should bring into the conversation a negotiator, right? I'm just using my intuition, but when you have a group of people, or most of the people in one side of the opinion, if I was a negotiator, I think that I have more elements to bring them to the other side of or to negotiate something in exchange. But when I start with a facade and I have Adenas there, who do I negotiate with? Who do I bring here, who do I bring there, and why? And then that's kind of intuitively, but you are making the point that I should probably be talking to an expert. But at least intuitively, it kind of makes sense, no? That you don't want to have a divided room to make negotiations. You prefer to have one in the rev, but then there the negotiation start. More or less, that's my intuition. Yeah. More questions? Online, more questions? No? Okay. So I know that you are tired, so I'm going to give you just 5 minutes so that people stretch and dances a little bit, because I'm sure that you are like, everyone is partying down there. Why is am I listening here crazy talk? So why not 10 minutes, please, and then let's stretch and let's see if we can dance a little bit, and then we come back. So let me finish doing some of this boring part, walking you through the coding. I really hope that you have some time tomorrow in the morning, if not tonight, to go through it in the Google Drive. Just press enter and see it runs, change, of course. I am just assuming that you already know enough to know that you need to change, for instance, this part, no? The CD part is in my file, so you have to change it. And maybe tomorrow we can have a few questions, but mostly tomorrow we are going to let you discuss your cases, your choice sets, and we are going to give you feedback. Hopefully everyone comes with ideas that we can destroy and make them better. That's the goal. Okay, so I told you we run the models, we see them, we interpret them as I did, slowly but surely. Then I ran these lines for every model to estimate the betas, the ones that I just showed you, the distributions, which are interpreted as the parameters that are attached to each of you. So just for you to understand what I mean by those betas, let me open the data file. Oh, nice. I'm going to forever remember this. Yeah. So this is what I mean by the betas, right? Like once you run the model for every person in the data set, that green ML is the parameter associated with how much you prefer having green that comes from the mixed logit model, or for parking, or for facade, or for lane. And then MLC, green MLC, is the parameter that arises from the model that is the mixed logit with correlation. So I have the two there. And I have one for every person and one for every parameter. Of course, with the exception of price when you run the price fix. Look, I have them for them, for all of them. How many people do I have there? 166 people. Okay. So with these coefficients, I can do something super cool. All these lines is so that I put all my betas together. And then I create the data sets called betas. Then with these lines, I am doing graphs of the distribution of the parameters, which are the ones that I showed to you before. I count how many are in the positive and the negative, which is what I told you before, 60-40, I think. But then I can calculate the marginal rates of substitution, which is what Charu and Sangeeta explained to you before. If you take, let's assume for the time being that you have a price in the discrete choice experiment. If you take the parameter of any one of the attributes, the parameter associated with any one of the attributes, and divide it by the negative of the beta of the parameter of the beta of the price of the parameter of the price, you get the marginal rate of substitution between that parameter and money, or what we call willingness to pay. So that's what I'm doing here. Because in this example, I do not have money, I prefer to keep calling them, generally speaking, marginal rate of substitution. So here I am calculating the marginal rate of substitution that arrives from the mixed logic model without correlation between green and parking. One of the reasons why I'm converted the parking in percentages is so that actually I can interpret this practically as elasticities. Is the change, the percentage change, no? How much percentage change you want given that you are giving a 1% of parking. That's why I'm calculating this, elasticities. For those of you who are very good at microeconomics, these are elasticities. So I am calculating the elasticity of substitution between greening and parking space. And the next one is between greening and facade space. And then the last one is a substitution between greening and presence or absence of road lane reduction. Those are for those that come from the model without correlation. Then these are those that come from the model with correlation. And then I am going to graph them. All this is the graphing, okay? So let me show them to you. Just for you to keep in mind, the ones that I showed you before are the parameters coming from the model directly. But they don't have interpretation, but with the sign. That's why I only talk about, well, you know, some of them are in the left, some of them are in the right to the zero, but that's all. These have interpretation. Let's start with facade. This is the marginal rate of substitution between green space and facade space, or as I told you, because they are in percentages, these are elasticities. And then here is probably more obvious what I was telling you before. For 50% of the people, or 50% of the density, not the people, 50% of the density, in both of the distributions, it's even more clear here, have a negative marginal rate of substitution and have a positive marginal rate of substitution. This is a very contentious topic. Let me present the other one and we interpret the parking. There. Parking. Clearly there, the highest percentage of the density is in the right. There, people are willing to trade there. So, if I remember correctly, I don't have the number right now, but you can see, for instance, around here is like 2. Yeah, it was around 2. So for every, so if the average is 2, for every percentage of parking space that they give up, they are asking for 2% of increase in green. so twice as much. I have not talked to my colleagues. We have to discuss this. I don't know whether this is asking too much or too little. I need to see whether it's possible to cover that they are asking for. But that is the rate of substitution of the people responding, which again gives me the excuse to link it to policy. Let's imagine that when I go with my colleague, one of them is psychologist, the other one is a social worker, and I think they are working with the person who is in charge of nature-based solutions. The basic public policy conversation is this simple. As economist, I am calculating that we can take off 1% of parking spaces as long as we can guarantee that we are going to increase in 2% the green. So the question to the person who is expert in the nature-based solutions is, can we do that? That is how powerful these numbers are. I want to emphasize on that. It gives you the parameter that allows you a meaningful, straightforward conversation with other disciplines. In this case, with the person who is in charge of greening urban spaces, right? But it could be a marine biologist, it could be an ecologist, it could be a landscape ecologist. As long as the number that you are obtaining is a parameter that allows that communication. So I am not expecting you to have it that clear in your first trial, but try to think a little bit on that. What will be the parameter that I get from my discrete choice experiment, and what is the professional that can answer the question whether the preference of the people in my sample are reasonable or they are just very unreasonable and nothing that we do are ever going to give them 2% of green for 1% of parking. Because basically that's what we are obtaining there. How much do we need to come forward to convince them to give up parking? If we have the 2%, these numbers say, well, they are going to come forward. That is how you want to start interpreting your numbers coming from your discrete choice experiments. Okay, let me just show you one more line. Something I wanted to show you. Facade. There is less obvious. Facade. Okay. So up to there, remember what I told you at the very beginning. You don't want to talk or think about respondent or individual specific characteristics at the very beginning. Right now, we have not been even mentioned whether this is for richer, for poorer, for educated. We haven't mentioned nothing about that. This is what happens in general, in the general distribution, the general preferences. Now, I want to take advantage of this figure to start motivating how you could address potential differences in preferences that are associated with the individual characteristics. Granted, you will see later on that even when this, I'm going to be doing some fancy latent class analysis, it comes less interesting than I was hoping, but I think that the storyline is pretty. So I'm going to keep in this one, and then later I probably go back to our work in transportation. But basically, I want to give you an intuition about what is a latent class model or what is a finite mixture model. I like to call it finite mixture model as it is actually technically called, because finite mixtures mean what it means. You have a distribution, and that distribution, that empirical distribution, really cannot be represented by one distribution or one family of distributions. But instead, it can be represented by a combination or mixture of distribution. And it's finite in the sense that it's a number that is finite. It can be represented by mixing by mixing 2, 3, 4, 5 distributions. After you have 10 distributions, that is not a finite mixture anymore. It becomes very continuous. But how do you know when some distribution could be represented by a mixture? As I told you before, when you have bimodality or multimodality in a distribution, suspect that you need to test for the presence of finite mixture distributions. So when I saw this distribution of preferences for facade, so with my experience, I thought, finite mixture. Why? Because what we have here is not a distribution that goes like this, but we have two distributions that go like this. Look. Do you see it? That's what you have there. And notice how the cool thing here is that the two models tell us the same story. There are two distributions here. You could potentially represent these preferences better if instead of trying to represent them with one normal distribution, you try to represent them with two normal distributions that have different means. One is going to have a mean around here in the negative, and the other one is going to have a mean around here in the positive. And that in itself is already telling us part of the storyline that I was telling you before. We have a group of people that don't like to give up facade, or are not willing, or are very unhappy, which will be these ones. And we have a group of people that more or less are happier of giving up. So that is the motivation to run a latent class model of ordinary least squares, which is different of what we did in the paper with Charo. Here what we are doing is we run the mixed logit, we graph and we study the distribution of the parameters. We kind of suspect for latent class, for presence of latent classes, or for the need for finite mixtures. And then we go and run. Remember, you have all access to this in the, so go and check it. This is how you run after I graphed. All these lines are for graphing. The way. Oh, sorry. Here. To way. And then I went and I said, okay, let's run a regression. Here it is. On each one of those marginal rates of substitution. We are going to pay attention to the one between green and facade just for purpose of focusing. Then I run the regression and I will show you that, not surprisingly, look, green facade is this one. But for the purpose of the argument, check how when you run an OLS, a simple OLS, trying to explain the marginal rate of substitution of between green and facade, nothing becomes significant. It doesn't matter whether you are older than 54, if you are female, single person household, 2 or more cars at home, which I thought that should matter at some point, and if you are homeowner, nothing is significant. And the reason is the distribution that we just saw. Nothing is going to be significant when you have a distribution that doesn't come from a normal distribution, but from a binormal distribution. That is what motivates two classes mixture model, which is why we estimate this model. So here we estimated the OLS, all this is OLS, nothing is significant. And then this is the line for when you run a finite mixture model. The command is FMM. The 2 in this case means two classes. And I really like this command because the rest is the same that if you were going to run a OLS. It's the same line. The important thing with this command is very flexible, that lets you run finite mixture models of any specification that you wish. Poisson, binomial, any specification. So you could test different types of specifications. And then here you say predict, please, the posterior probabilities. And I am going to use the posterior probabilities to assign people into classes, depending on the probability. So there I'm going to stop a little bit before I show you the results, to give you a little bit of the taste of the EM algorithm. So whenever you have the intuition that I try to motivate to you with those graphs, and you're on a finite mixture model, the EM algorithm it's an iterative algorithm that is very intuitive, but because it's iterative, it's going to take forever. Why? Imagine that I am suspecting that that I can group you into groups of preferences, okay? For chocolate. Half of you don't like chocolate, and half of you love chocolate. Let's see if I can do that, right? Anyway, so the way to start this expected maximization algorithm is by simply randomly allocating half of you in this side and half of you in this side, and say, how does the likelihood function looks? It looks kind of crappy. I'm going to take some of you to this side and some of you to this side. How does it look? Is it improving? Yes. Oh, then I'm going to keep doing this until the likelihood function looks like it's reaching its highest point. The problem with that idea or that implementation is that if you start in the wrong point, if you start and then you pass already the point of maximization, you get lost in the nothingness. It just keeps running and running and running and running. Or if you started too early in the maximum likelihood function, it takes 3 days to reach the highest point. But that is the general idea. The general idea is I'm going to reorder you, and I'm going to guess if that is the right ordering. When I say how does it look in terms of fitting, you have to have in mind this distribution that I just gave you, that I just showed you. Once I reallocate you, and I say, okay, I want to see if with you here and with you here, your preferences are, if I draw your preferences, does it fit well this pair? Does it fit this well? Ah, no, this is another one. Does it fit well the two supposedly existing distributions here? And then I stop when I am able to fit. So the method assigns probabilities of you belonging to each of the classes. For you, I'm going to have the probability that you belong to class 1, that is 0.7, and therefore the probability that you belong to class 2 is 0.3, right? Because you can only belong to one or the other. So what I do is once I run the model and I say, okay, the model says that I got the best fit, is that if you are with 70% part of class 2, I assign you to class 2. If you are with 30% with 80% in class 1, I assign you to class 1, and so on. I do that a posteriori with the posterior probabilities that come from the model. That step has its implications. It's not because it's based on probabilities, and sometimes I am doing it with probability 51%, right? So while it has some problems when I assign you to class 2 just because you have 51% of probability to be in class 2 instead of 49, no? But granted that, I want you to see what comes when I do that, and then I will show you the regressions. Okay. So this is how it looks when I don't do latent class models. This is for everyone. This is the one that I showed you. This is the marginal radius of substitution between green space and facade. And this is how it looks when I use latent class models. I have one group that behaves like this, and I have one group that behaves like this. Does it improve my understanding of the preferences? I don't know. You tell me. I want to show you the results. Let me see if I can explain them. No, this is green parking. Oh. Here. This is the one. So, what happens is for the case of facade, there are two classes, and the people who is in a single person household is less likely to be in class 1. And the people who have 2 or more cars are less likely to be in class 1. And the people who is a homeowner is less likely to be in class 1. So I am obtaining the chances that you belong to class 1 or to class 2. Now, what comes later depends a lot of interpretation. What does that mean? Does it mean that the people who have more cars also like their facade? I don't know. To me, the important result here was this. The people that dislike to give up facade are the ones that are homeowners, which makes sense. If you are renting, you're like, sure, whatever. But if you are homeowner, you were like, no, I don't want to put anything in my facade. It's my facade. My house is going to be losing value. These, for instance, the fact that they are at the same time the ones that have 2 or more cars kind of makes sense. But in this case, it's more association than explanation, I think. But at this stage, this becomes very subjective, the one who has to be interpreting this, and I haven't sat with my colleague, is the one that really knows the context at this stage. Because I don't know exactly what to do with that. That's kind of my message. My message is, we can do it, I can do it. I'm the econometrician here. There, boom. The interpretation at this stage cannot be done by myself. You have to get it back with your colleague that knows the very context, so that she tells me, what does this mean? I kind of am making sense of this, but I am not making sense of these ones. For that, we need to know the context. So that's how I wanted to motivate the use of, once you do the conditional logit, you run your mixed logit, you pick between your mixed logit correlated or not correlated, you graph your preferences, you try to see whether you should be explaining those preferences with socioeconomic, with individual characteristics, either with an OLS or with a finite mixture model that explains this kind of grouping. But that is the stage at which we include individual specific characteristics, in contrast to the regular OLS or the regular logit that puts the individual specific characteristics in the equation. Here you first analyze whether people react to your discrete choice experiment, and later on you try to see how that reaction depends on the individual specific characteristics. This is one method. We implemented a different method with Charu. There are other papers I have used that implement a different method. My main point is, do not try to explore this individual specific variation in the conditional logit or mixed logit, because you are going to run into much trouble, and it is not worth, because it's not that intuitive that it should be done. I'm going to present to you one more example of what we did with one. There was one initial question. I don't remember who made this question, or I don't remember if I am actually making it up and I only interpreted it. But what are the welfare measures of interest? That's how I interpreted the question that someone asked. How do you know whether you want to study the marginal willingness to pay, or whether you want to study the willingness to pay for what? One of the interesting things is with the discrete choice experiment, you are always going to be able to obtain marginal willingness to pay. Right now, my thing is getting tired. If the computer is getting tired, I guess we are getting even more tired. But basically, what we do in this discrete choice experiment, we went to the Peruvian Amazon and we asked the leader of the indigenous community, as a representative of the indigenous community, to evaluate whether he thought that his or her community were going to be interested in these contracts. Option A, option B, option C are contracts. The option C is the current situation. The option A and B are ways that the community could obtain a land title for the land that they have and have had for any number of years, but they don't have a land title. I bring this example because it's the first example of doing a discrete choice experiment in land titling studies. Economists have been studying the importance of land titling since 1980 at least. I remember doing my literature review, and I remember a lot of papers since 1980. And they used to do it in the regular econometric way, and then later on they started doing experiments. You give titles here and you don't give titles there, and then you come back 5 years later. But the motivation of this discrete choice experiment is doing that type of experiment is very expensive, and two, usually it requires the coordination with the specific government, and you never know in those contexts whether the government 5 years later is going to still be there or is going to want you to come back and keep the study. Actually, we did this in the context of doing the baseline to implement a titling program in Peru, and 2 years later it vanished. We were not able to implement it. So at least we have an estimate of how much the leader of that community think that having a title is worth, which is an approximation. If it is not the revealed one, it's an approximation to how much titling is worth for the communities. That is the goal of this. So we told them, well, you could be paying this monetary cost per year for 5 years. This will be the quantity that will be titled, either what you have currently or 20% more, and we also increased it for 40.
So,
yes.
This title we're talking about?
It's a land title. If the government was going to provide you with a title, you could obtain it, paying this much for 5 years.
Okay, so it's ownership right?
Ownership is private. Well, actually, that's a good question. It will include the community owning the land,
Not individual, but the community.
and the parcels owned individually. So they will have a communal property and individual property on what they are working today.
So this is Peru.
Peru, in the Peruvian Amazon.
So before this, they didn't have a title?
Not there. They have.
Any system of household responsibility system, like where all the land is owned by a community?
Yeah.
By government?
Not by the government, by the community. What happens is they have owned it in the way that we call traditional rights, which is basically when the Spaniards came, someone said, well, we own this, and then the Spaniards respected that, and since then it has been like that. But if you go today and you try to ask for a title like today, there is no such a thing. So it's generating a lot of problems, because there is no clear delimitation, there is no clear measurement and all that. In that context is that they are trying to put this title. Very importantly, in that context is whether the title was going to include or not land that they consider traditional uses, which include magical purposes or ritual purposes, that kind of traditional use, and it's very important that it is included in the land titling.
Thank you. Just asking out of curiosity, whether you surveyed community heads here or individual households? So how you did this survey?
We went for community leaders in the moment that they were. The question was, imagine that you call for a community meeting, and you were presented to these options. Which one do you think that the community will go for in that meeting? That, for instance, is a good question, because we have to rely on the fact that he's giving us the answer that he thinks the community is going to give, and not his answer, which is shady, no? And we didn't implement questions to make sure that we didn't know how to make sure that he was saying that what the community would have wanted. We discussed whether we should go for households, but because it included a big component of community owning, it needed to be at the meeting level. We discussed whether we should actually go and there is this discrete choice experiment that are called collective discrete choice experiments, I think. That basically you put the discrete choice experiment in the table, and you put everyone to sit and to discuss, and to then come up with an agreement on which of those options they will choose. There are a few papers doing that. We thought that the topic was not deemed to be, we will be creating more problems than solutions if we were going to be putting communities to discuss this. So we thought, now let's just go for the head. That's why we did that. The component of whether they will include traditional land, that was an important attribute. The other one, of course, duration. Do you want it in 1 year or in 5 years? Or duration that the process takes. And then an important one was, that's one we identified through focus groups. They didn't trust the government too much, so they will want to have, some of them, representative of the regional indigenous federation in the team, discussing the title, so that they had more trust or not on the exercise. So what I wanted to show you is, by the end, of course, we do the same analysis that I presented to you, right? Mixed logit, and then after the mixed logit, we explain willingness to pay with characteristics of the community and the respondent. Now, this thing is not working bad. In this case, we didn't explain marginal willingness to pay. It doesn't make sense to explain the marginal willingness to pay for 1 year save, for included or not included in the territory. What we did was, we calculated the willingness to pay for the best contract. So the contract where they will get at least the territory that they say is theirs, they will get the traditional land title, they will get it in 1 year, and they will get it with people representing them in the team. We added the marginal willingness to pay. We calculated the willingness to pay for that contract, and that is the one that became the dependent variable in our regression, like the one that I presented to you before, the OLS. In that case, we didn't do latent class model. If this thing was working, I will show you how there is also a very good distribution of preferences, but I think I will have to restart it because, let me try the control alt.
Maybe too many files are open.
Yeah. Let's try one more time. So what I want to emphasize is this. What we did was we ran the mixed logic that I already presented to you here. Then we estimated marginal willingness to pay for each attribute here. But that is not really the relevant thing, right? The relevant thing is how much they will pay in total for different contracts. In this case, we created these contracts, option 1, option 2, option 3. And then once we have that willingness to pay, that is the willingness to pay that we wanted to model in terms of the respondent characteristics and the community characteristics, which is here with an OLS. The important result here is the one I want to emphasize is, yeah, the people who had the community where they had ancestral ownership, they clearly were willing to pay a substantial amount of money for having their land rights. There was a difference between communities. San Martin, which was more farther, more remote, was less willing to pay. And the more land per family they had, the less they were willing to pay, which we interpret as they really were feeling that they didn't lose too much if they already have enough land per family. So just to summarize there, the willingness to pay or the preferences that you want to explain based on individual characteristics depend on your own study. Sometimes, like in the first study that I presented to you, you want to explain marginal willingness to pay. In some cases, which are more cases than I believe they have realized in the literature, you want to explain willingness to pay for contracts. And the reason why I am talking about that is because that is what usually relates to policy. Once you have created your discrete choice, everything, don't overlook, don't forget why you did it. And now I remember the question that someone asked me. Someone asked me, so if I want to keep a discrete choice experiment, or someone asked us, if I want to keep an alternative with this and this and this and these characteristics, how do I do it? You don't have to keep a specific alternative with a specific characteristics. But if for whatever reason that is an important contract, an important alternative, once you run the regressions, you can estimate the willingness to pay of the respondents for that alternative. If you think that that is the alternative that optimizes this, or that the government can really provide, or that, I don't know, that is the one that you want to later on see how the willingness to pay for that alternative varies by individual specific characteristics. Okay. I think that's where I wanted to end.
Very good.
Well, we survived.
I know.
Any questions?
Very intense.
Don't feel afraid. You can throw questions while I close the session.
We'll then have students' ideas.
Yeah. So that's what we are going to do. So today we would like to hear a little bit of your ideas.
Yeah, we'll just hear a little bit of that.
And then tomorrow we want to hear a lot about your ideas. So today give us a little bit of a taste. Sangeeta and I, we will be giving you feedbacks, throwing just basic feedback, and then include it. And tomorrow come ready to justify and defend your discrete choice experiment.
Yeah, you can sit wherever comfortable.
Let me sit here.
Yeah, we are the team of 6 to 7 people, and we, as far as we have discussed whatever, so I'll brief you about that. We will be discussing more about in further few hours. We are planning that choice set you told to describe. We have to describe that choice set or an alternative with attributes. So we are deciding on like in NCD there are some precautionary health behaviors. So we are taking 3 to 4 attributes of precautionary health behavior, like visiting OPD for the precautionary health checkups. Another one attribute like sugar intake, one more attribute like salt intake, and one more attribute for physical workout. Then the levels we are setting, like the prescribed consumption of salt in India is 2 gram per person per day. So we are taking the limit as less than 2 gram, 2 to 5 gram, and more than 5 gram. So less than 2 gram will denote the bad health, good health seeking behavior. 2 to 5 gram will moderate health seeking behavior, and more than 5 will denote the bad health seeking behavior. Similarly, for the other things like sugar, for 5 gram, 10 gram, and more than 10 gram, we are categorizing it at a good, moderate, bad health seeking behavior. Like in the car example, starring of cars, high 5-star, 4-star, 3-star, we are titling it as good health seeking behavior, moderate health seeking behavior, and bad health seeking behavior. So similarly, for the OPD visits, we are prescribed to have one OPD visit for our for our blood test, regular blood test after the age of 35 for every 3 months or 6 months. So if we are visiting every 3 months, we are setting it for 3, more than 3, or less than 3 months. So similarly, it will be categorized as good health seeking behavior, moderate, and bad. So we are planning to get a policy package which we can market, and we can ask people to how willingly you are willing to pay for that package of health seeking behavior, to follow that health seeking behavior that will help you to go for workout, to consume less salt, to consume less sugar, to go for OPD visits. So like this we are planning.
That's interesting. But is it like they will be buying a little insurance for having that service, that medical service that will?
No, there will be a kind of nudge policy can be there. They will be getting daily reminders how much consumption of salt. So how, for a complete package of this following a good health seeking behavior, how much a person is willing to pay for it. So a policy package can be there.
Okay. But how will they pay?
How will they pay? That we have to figure it out.
Okay.
Yeah.
But we need to figure that one out. Think in terms of insurance. I don't know if in Mexico we have small providers of kind of a semi-insurance type of policy. Not really big providers that they say like pay me 100 pesos, which is very little, and then you can come and do your checkups with us, and then they do basic checkups. So it's like a very basic service that if you buy, sorry, thank you. A very basic service that if you buy, at least you know that you are not in terrible condition every 6 months. So something like that probably, if you guys have some of those services here, that will make it kind of realistic, the payment, okay?
Yes, sir. Actually, we are on the same team. So I really liked your suggestion. So even when I was studying, so there is no insurance policy for the middle class people in India. So the insurance policies are quite high, and it's like Ayushman Bharat is there, but it is limited to certain section of the people. So maybe we can also look into like what services we can provide to the middle class, and how they can choose between like what is their preference. So that was also good for the policy thing.
So I'm in the same group too, and another thing that we were discussing there was like if you go to any of these medical applications where you buy medicines, so whether you're going for Apollo 1mg, they always have these packages where you can subscribe to these services where you want like regular health checkups, or you want these packages to be sent to you for your medicines, for your food that are specifically made for people with these current ailments, or like just even for preventative measures. So yeah, that could be the product.
You should follow that type of example that already exists in the market. But something that will be a contribution will be what that is not in the market will your package be providing. Okay, what attribute is it there that is not already offered?
Actually, health insurance, it is like it's more of curative. You will be getting a treatment afterward, but we are working on preventive and precautionary measures.
Exactly.
Like, so we can't rely on health insurance for that. So we need a different type of policy or something, algorithms in our phones or kind of thing, which keep on nudging us to follow that good health seeking behavior.
Remember the
and
nudging.
Moderate health seeking behavior.
Remember the nudging. I remember that when we talked for the first time, the nudging was important.
Yeah.
So that because it's something that it seems that needs to be nudged in order for people.
Yeah, it's in middle of not even compulsing you and not even liberating you from something, but it's something that would push you to boost you, motivate you to do that.
Very good.
Yeah, it's might be phone call reminders, message reminders, kind of thing.
Probably Sangeeta
That
has
would help
something to
you
say
too.
because it's part of your topic as well, right?
No, very interesting exercise that you guys are thinking, but I'll suggest that you start thinking in terms of what is your research question, what is your objective, what do you want to, estimate and aim at, what kind of trade-offs are you? Because when we do discrete choice experiments, we're thinking about trade-offs. So what are these trade-offs that you're thinking about modeling? That's my first suggestion. Second suggestion I have is that, when you're saying that 5 grams of salt, maybe put it in a manner that you can relate to. So do you know how much salt are you taking on a daily basis?
Ma'am, there is a 4 pinch in 2 grams. So for make it easy, usually the nutritionists and dietitians take it as a measure for in a layman language, so you don't have to calculate every time.
That's what I was thinking. So I was thinking that maybe the innovative way of doing it would also be like a pack of chips, because you know how much salt is there. So those kind of trade-offs, that will you have it once a day or once a month. Similarly, sugar, instead of saying 5 grams of sugar, you could say that will you have dessert every day or just once a week? What's the trade-off from having it every day to once a week? And the trade-off would be that, okay, I can have my dessert, but I'll exercise for 1 hour.
Yeah.
Compensated.
Yeah. Right? So then there'll be a trade-off that, what do I want? I'm lazy. I'll say, okay, I don't eat my dessert, but maybe I'll eat my dessert and also work out for 1 hour.
Yeah.
So think about a little bit in terms of trade-offs and options which are more relatable. So I know a packet of chips, and it'll be written on that packet of chips how many grams of salt. So it's something, so nutritionists, they're saying 2 grams per day. But I mean, where does that 2 gram come from? So, am I willing to give up my snacking? And, so just think a little bit about those trade-offs. And in terms of, so it's not about a medical insurance, it's more like a checkup plan which you have in mind. So preventive checkup plans. Yes. But, people don't need to do it every 3 months or something. That'll be too much, right? So maybe every 6 months. I don't know what is the recommended thing.
But that if we are targeting people of 35 and plus, so they are recommended to have
every 3 months.
Every 6 months.
Yeah, maybe 6 months.
People above 50, they are recommended every 3 months. Like this is the thing.
Really?
For glycosylated hemoglobin.
But interesting. But just think of like making it a little bit of trade-off, bringing some trade-off, and something that you can relate to. Because see, nobody wants to have too much salt. Salt is something that everybody is having something within a range. Because if I put too much salt in my dish, it's not even edible. Right? So within that range, you'll have to create something. And to me, it's more like, you include a snack that can I resist having that popcorn or chips? You go to a movie and can you resist having popcorns and cola? Because for sugar, it's like, cola. That has a lot of sugar. So just make it a little bit more relatable. Okay? Any suggestions from the group?
Can I complement a little bit? I really like how Sangeeta presented it. You should do, I have this one. You should do like a good illustration probably with the products that are more related to like how many Coca-Colas you have to drink as much.
Yeah, you have to, give up.
Yeah. But then I also like how you said the exercise, right? Yeah. So you could include in the discrete choice experiment the measures that you could implement to compensate, because also if you have that kind of checkup and you have to pay for having the checkup, with the technology nowadays, if you allow the provider to have access to your phone, they know how many steps you are doing or so that the price is tied to your level of exercise. Yeah. So you could do that type.
Most of us have that map, no?
Yeah.
Many steps. So.
If you can show that you did these many steps and then you kept your sugar consumption under this, you will be paying this. Yeah. And if you cannot. Exactly, compensate. Yeah. It exists?
This scheme is already there in, I think, Galaxy Watch, this step thing. They made it a marketing scheme. So if you walk for a month, if you exceed some steps, so they will give you that much of discount in your bill. There is one marketing scheme like this.
Yeah, that's a good example.
That's a good example. Take advantage of that one to make it a health check-up kind of program, no? Because the thing is, walking is not enough, right? Like you need a medical provider to tell you, oh yeah, you are having walking, and you also, because sometimes what happens is you walk, but then you consume more sugar, and then and then you end up worse.
Yeah, it's like, oh, today I did so much of workout.
Yeah, exactly. Very good. We have one hand there. Thank you. Thank you, health team. We are going to call you health team.
You guys have started thinking about it. We're really glad about it.
Yeah.
I was thinking if they could add this element that if they follow this particular plan for a month or 2 months, they could get some discount on the next month checkups.
Exactly.
So that could be one of the nudges they can have.
Yeah. That could work as a nudge. Very good. You are the health team. The healthy team. Who else? Here, we have one hand here.
You can also introduce yourself.
So, I'm Ishita from CITD department, JNU.
MA first year.
And we have formed a group of 3, and we are planning to design a DCE on circular economy in clothing, where our goal is to understand the willingness of the people to switch from a fast fashion industry to a more sustainable industry for fashion, so that we can reduce the overconsumption of resources in that sphere. So for this, we are planning to use earth codings, like as we discussed in the examples here for cars and fridges, we were using stars, high label, low label. So here we are planning to use earth codes like green, yellow, orange, red, which will show the environmental impact and the sustainability, how sustainable is the material. And for that, we are planning to use some attributes. There are 6 attributes. The first one being material, where we have divided it based on low, moderate, and high sustainability. Then we have durability based on washes and the number of years the clothing might last. Then we have take back programs, like whether it is recyclable or not. Then we also have price, biodegradability, and performance. Performance is based on stain resistance and sweat absorbance of the material. And for price, as we had seen here, determining the prices based on the graph where it was between 80% and 20% variation, we have also conducted a small survey through a Google form to get the down the sloping curve and check if we are getting it that way. So we have researched a bit about the prices, like what can be the cheapest, what can be the most expensive, and we have taken a lot of prices in between and put it up in a Google form where people have responded how much they are willing to pay, and we are getting a
what is the
downward
range?
sloping curve.
Do you have
It's-
already the range?
Yeah, it's from 350 rupees to 1250. It's for a t-shirt based, considering a conventional cotton t-shirt as the baseline, we are considering the price to be 500, and from 350 to
It's like five euros.
Yeah.
350, 5 euros to
1250, 1250.
15 euros.
It doesn't seem too crazy. It seems like a reasonable number. Yeah. Very
So-
good. I mean, with the technology nowadays, you can do a lot very fast. Very good. Something I wanted to tell you about that is one, if you could kindly send me an email to remind me later today, because I don't have internet. But one student of mine did that finished her master, did a discrete choice experiment with this motivation. The attributes were very different. She went for how much will you pay for buying clothes that include repairment, so that you don't have to throw them, or you don't have to, so that you can repair them for as long as you need it. But then she has a lot of the introduction, a lot of literature review. It's going to be helpful for you to get into the topic. So I'm going to send it to you if you send me an email to remind
Sure,
me.
sir, sure.
And the other thing is, some of the things that you are presenting are good. Just consider doing also your semi-structured interviews and your focus groups, because durability, of course, you want to give up fast fashion. So I can see how that is an important one. But the ranges also are interesting. I don't know for the rest of the people, but I have, probably should not say, but some of my clothes I have been using for at least 10, 15 years. And to me, that is just amazing. But I know I have noticed in younger people that they are not happy if you tell them that. Like too long is like 5 years, right? So do your semi-structured interviews to know how long it will be too long without getting people scared.
Yes, so the duration and the longevity attribute is also representing a trade-off with the fashion trends. If I purchase a cheap cloth like polyester or nylon or something, not nylon, like viscose or rayon, which does not last very long. So that might work with the fashion trends because I'm paying less for it, and it is a trendy cloth compared to what is going on and in fashion right now. It is not lasting very long. I'm spending less on it. So after 2 or 3 years, I buy another one which is consistent with the fashion trend going on then. Compared to that, if I buy something made of organic hemp, which is really very expensive, about 80% of the base price of conventional cotton, and it will last very long, but it also matters that if I want to go on with a type of a t-shirt that is not going to be trendy 10 years later, but it will last till that time. And am I willing to spend around 1,000 or more amount than that on such a piece of clothing?
Oh, you have a really interesting topic. Now I am thinking whether the t-shirt or the pants should be the case, right? What do we want to keep longer? I mean, I am also thinking on the age of the respondent, because if you ask a 15-year-old, I don't think we have too much hope. And I also think that we should let them be responsible, because, you know, it's not like I was a very responsible one. But then we probably should be asking people what, maybe 25 and above.
Yeah.
Right? That we at least that age, we probably should try to ask people to be thinking more responsibly.
The survey we did had mostly younger age groups, like college students and
college and above.
Yeah, college students who are mainly more concerned about fashion trends.
Yeah.
It was for the price range, and then we are just making choice sets as of now. Right? Yeah, 18 plus.
Yeah, 18 plus.
18 to 24, 25.
That's when people start getting responsible. Okay.
And after we make the choice sets, when we can send people the choice sets, then we'll be able to make distinctions, like how they are able to how they are presenting their preferences, because we are planning to make 4 to 6 choice sets, which will help us determine how do they respond to the coding factor, because in some choice sets we have a lot of attributes that are similar in the two, but a few attributes that are different, which will help us determine if coding is important for them, if longevity is important for them, or other factors.
Perfect. Okay. One general comment I will make is that don't forget to start thinking on your questions prior to the discrete choice experiment. What do we want to know about these people in terms of perceptions, in terms of social network, in terms of intrinsic motivation? For instance, in your case, probably more than in the first case, intrinsic motivation and extrinsic motivation should matter. In our results, one of the important things is extrinsic motivation. When people were extrinsically motivated, that's when the network effect remains. And it was something between 40 and 50% of the people. So half of the people need to be extrinsically motivated. So that will be interesting to also document in your study, because basically maybe, just maybe, it becomes trendy to be more responsible when wearing the clothes if an influencer gets on board of the campaign. No? And that could come out from your study.
The social network might be an important factor here. So I just wanted to ask if we already have 6 attributes. So if I add another one, it becomes 7. So we don't want a lot of attributes as well.
For tomorrow, as many as you want.
Then I'll add a social network attribute. I think that is important for
tomorrow. Sangeeta and I will be destroying it so that you build a better one. So for tomorrow, bring your best options and whatever you have thought. And tomorrow we discuss it.
Thank you so much, sir.
Thank you. Very good.
Very nice.
Bravo.
Clap for all these proposals. Within 3 days, they've been able to think.
Yeah. We have one more there.
One more, Khushi, or there, Bhavna.
I am Bhavna from CSRD JNU. So we are a group of 5 people, and we thought that we should work on solid waste management. And we had a very good discussion with Sir also yesterday. So we all know that it is a very big issue, and almost 50% of the waste that is being generated by in the area in India is not actually recycled. It either goes to the landfills or either it is unaccounted. So we wanted to target. There could be different levels at which this segregation can happen, but we want to target it at the household level. So basically, what if we plan to motivate the households to segregate their waste and then dispose. Then they send it to the garbage. The person who comes for collecting the garbage. So we were thinking of different type of questions which we could look at, but we here want to create a hypothetical scenario that government is planning to come up with an action plan to for the solid waste management, and it will be charging fees for the garbage collection. So basically we did a quick call to a few people and tried to understand, and based on our experiences at our houses, what is the scenario. So this situation is based in Gurgaon. What happens there is there could be either a public waste collector or a private waste collector. A public waste collector usually comes with a van, and it charges a nominal fees from say rupees 30 to rupees 50 every month to collect the garbage, and there is no segregation happening. And if there is a private waste collector, it charges somewhere around 100 to 150 rupees per month, and again no waste segregation is happening. So the hypothetical scenario could be that government is planning to come up with a garbage collection fees which could range in between 100 to 150 rupees, and you could get a rebate on this if you segregate your waste. Then we have different attributes in this. The first would be number of days of collection. Current scenario is that the daily the garbage is being collected, so we could vary these number of days. Second would be segregation. Segregation into no segregation is the current scenario. There could be two levels, which is segregating it into dry and wet waste, or segregating it into wet waste, recyclable waste, and non-recyclable dry waste. So basically 3 types of segregations. Then there could be a rebate, which obviously I thought that we could keep it in percentage terms, like ranging from 20% rebate on the fees to say 60% rebate on the fees that is the government is charging monthly. The fourth would be the peer effect or the social effect, that what if 30% of your neighbors agree to this particular choice set, or what if 60% of the neighbors agree to this particular. So we can have 4 attributes and different choice sets based on these attributes.
Yeah, I like it. I pretty like it yesterday, so I have few extra comments, but what do you think, Sangeeta?
No, I mean, solid waste management is really an important problem in all these densely populated countries. The waste that's been generated in Delhi.
Yeah.
And governments have been talking about it. Even in my colony, every month there is something like they're doing segregation, but I know nothing is happening.
Mhm.
Even if at a household level I segregate, the person who's coming to collect garbage is going to mix everything.
Yeah.
So in Gurgaon, ma'am, what we have, what government planned, I was looking at some document also yesterday. They have these vans that come and collect the segregated waste. They were designed to do that, but they started with it for few months and then people stopped segregating it. So they actually don't have any incentive to do that, even if the government is taking some efforts in that direction.
Yeah, so
I have one good story though, like in the sense that. So in Bengaluru though, like where my parents live, BBMP has been doing this since I was in 8th grade. So that was back in 2013. So they've been doing it and it's been going on, like what you just said, that they did not continue with it, but it's still on. The biggest issue there though is the fact that people are working. So not everyone is at home. That's the only thing that people are willing to pay. So that's the price that people generally try to calculate, because these are BBMP workers, public workers, but people pay them extra. Okay, fine, if you live on the 3rd floor, if you live on the 4th floor, you don't want to come down with your waste, if you have a lift, you don't have a lift. So those are the bigger questions, but it is happening, at least in Bengaluru. It's like a very big thing. It's been going on for like more than a decade. Absolutely, like it's they will not take your waste otherwise. They will just refuse to take it. Like like your sanitary waste is separate, your plastic, dry waste, wet waste. Even in wet waste, like I said, there are so many categories. If you have like for example glass bottles or electronic waste, it's very well done there.
That's really good to know, because it's not happening in Delhi and we really need to do it. But yes, we want to understand what will incentivize people to do it, or what are the barriers and why it's not happening.
I will read about the case. If there is some reference that you could refer to her or anecdotal of any kind, so that also she gets a hand of what makes it successful, and that could help her to also to the design.
I have something to add to this. So my parents live in East Kidwainagar. It's near INA and Southex. So there the waste segregation is perfectly done. So what happens is the person comes, you need to segregate your waste. So 4 types of dustbins have been given to us. We need to do that. If any of the houses is not doing it, then what they do is the RWA will put their name, and as a kind of punishment that will be put on the notice board. So then people are really scared of it. And
no, nice.
Yes.
Yeah.
So it's been very successfully.
Let's try
done.
that one. I mean, the cool thing is do some piloting, do some interviewing, and see if people will get scared of that, and then you have it.
This is also your PhD topic?
It should.
Yeah, I mean, it's a good PhD topic. So women are taking the lead. Oh, where are men?
Ma'am, there's one more.
Oh, okay.
Would a guy want?
Is there any online which they want to share? Just check. Okay, yeah, you can introduce yourself. Meanwhile,
Hi, I'm Sanskriti. I'm doing my master's from CITD. So the problem that we wanted to tackle with our DCE was actually the declining labor force participation rates seen among women in India. So the exact problem that we were looking at was how job time requirements serve as a barrier to entry for women. Right, so we have seen and how that contributes to the gender wage gap. Right, so a lot of literature on this field suggests that there are preferences for occupational attributes which are different within the genders. Right, women have different preferences for occupational attributes that cause them to sort into lower paying jobs. Right, and these attributes are usually attributes that allow like family compatibility. Right, you get time to for childcare and such things, right? But a problem with estimating that empirically has been that the data that we see is usually like the equilibrium outcome, right? It's the result of individual preferences as well as employer preferences and the particular job attributes. So we want to see whether like how much women are willing to pay, right? Okay, so another thing that I would like to point out is employer preference. By that I don't particularly mean that there's discrimination, but something like women might have lower human capital, right? Women might be less educated or some issues like that might not fit into the job profile. So we want to see how much of the gender wage gap is actually caused due to personal preferences, women's individual preferences for more time flexible jobs, which end up being lower paying jobs as well, right? So we were thinking of actually looking at attributes like childcare facilities and there's also literature on an existing female peer group and how that influences one's decision to enter the workforce, and we wanted to see how much of their wages they're willing to give for more flexible jobs, or would they actually end up taking higher paying jobs if these facilities were available. So we are still in the process of designing it, so if you have any suggestions as to what other attributes we could include, that would be
again very relevant and interesting thing, and I think discrete choice is actually relevant here because market data will have indigeneity and self-selection.
So this, this literature has already documented that the data, observable data, will have self-selection and indigeneity problems. So you can't address this problem with observational data or market data, and therefore discrete choice is really important. And actually Adan has worked on remote working, so maybe you can talk about that. That's one thing you can include, that would women like if they had the option of working from home or working remotely. So I think he'll like to add on that.
I had some reactions, but the first thing I want to highlight is from now on, how I try to motivate how market data sometimes has limitations, and I try to use the housing and but from now on I'm going to use also the example of how to document wage gap. The market data cannot necessarily help us because endogeneity and self-selection and everything. So that's the one thing, and thank you for bringing that up. The other one is very important topic, and it is true that the discrete choice experiment can help us if we get smart. I'm trying to get smart quickly. I don't have a quick reaction. One of them definitely remote working should be something that will allow people to get better jobs if that is something that they want. Something important is going to be the pre-discrete choice experiment questions, because there, to me, what is very important is for you to gather what I will call the inherent preference of the specific woman. And I don't know how to call them, if goals in life or aspirations or
one study right now.
right? Yeah. So there you probably have something.
Perceptions.
And,
yeah, we're looking at their what are we calling this? The aspirations, perceptions,
goals, and their network. So their network. So that these are some of the things that we're looking at. Actually, we're doing one study. It's not DC, but that's observational data, and we are doing that in academia. And I'm just sharing with everyone. We're seeing that how women's career progression is getting affected by some of these things, and we are collecting very large data from maybe over 100 institutes in India, and we're going to department and collecting data for each and every women and men faculty member and seeing that what happens over the career. Is it that men get promotions earlier than women, and what could be the factors? So we are doing that. But to you, I'll add one more factor, which will be safety at workplace. So maybe some women don't want to go out and work because they don't feel it's either the commute is very safe, or maybe the workplace is very safe. In academic departments still we are very safe, but in many other places it may not be very safe, or at least the perception is that we could be exploited or some abuse, and that could also be a reason. So maybe you can find out, so one of the things could be that a safer working place. That's one thing you can.
In this project, we're also using norms.
Yeah, social norms. Yeah, we are also doing, social norms about things.
Yeah, in this topic, I will definitely go and sit down a little bit and learn about whether there are some battery of questions to gather this kind of aspirations, perceptions, social norms, because they are going to be very important in the moment that you present them to the discrete choice experiment. I need to think a little bit more about, in addition to safety, teleworking, childcare. That should matter. I need to think a little bit more.
The presence of POSH, that is Prevention of Sexual Harassment Act,
Uh-huh.
have a national level act, whether it is being implemented or not.
That should matter. Exactly. That's a good way to proxy safety, for instance.
I was actually thinking that we wanted to focus on hours of work, so hours of labor supplied. Also, because we have seen all of these papers where policies that were actually introduced to increase wages, right, giving tax rebates and things like that, that actually women started substituting. So like the wage increase did not have the increase in labor supply that we had expected. Like the people at the corner solution, they started supplying labor. So the women who weren't working entered the workforce. So labor force participation rates went up, but the hours of work did not actually get affected by it. So if we have if we are seeing that jobs with higher hours of work are actually paying more, then policies like that will not end up addressing the wage gap, right? So that was a question that we wanted to look into.
Yeah.
That's
Perfect.
an important question. Maybe women want to work half a day.
Yeah, but the reason for that is what we are trying to figure out. So how to get women to supply more labor, maybe, so that the wage gap can get bridged.
Perfect. I'm going to think a little bit more for tomorrow. You just gave me a good homework. One more. We have time for one more.
We have time for one more. So yeah, I'm glad. You can't allow women to take lead.
No, that's not issue with me. So I want to add.
You can introduce yourself.
I am Ajay Kumar, and I am doing my PhD from CIT department, and I have tech supervisor Sangeeta ma'am.
Very good.
And I want to add one more thing to that. I think we can also consider the what is the income level of household, because if we see if the household is with the very poor income level, then in that condition women they want the women to work outside the because they want the income support in that condition. But if we see the like in the higher income group people. So like the willingness to work from the household side, like the parents and also that I think will it it reduces like they do not want their like child to go out. And also in that condition we can also consider the it based on the caste as well, because if we see in in the sense of upper caste people, so the Brahmins are not like this segregation, but in the upper caste in India there is there is less willingness to send the
So that's like a social norm.
social norm, and also the income level of household is also the one of the things
Yeah.
which can impact.
And income, and that makes me think that for purpose of your study, you have to think on the population. So I imagine the discrete choice experiment has to vary by sector, population, income. So there you have to get it right in terms of, I would like to tackle upper or middle income households, or lower income. I mean, but then the attributes should differ, because I am guessing what the factors are also depend on the income of the household. So we have to control for the household income, but also when you come to what is the population, you have to be very precise in terms of income. Mm-hmm. Very good.
Okay, yeah. So, any further proposal? You guys were Tamanna. You said you guys are thinking about it.
something they saw in the morning, so
You can talk about it. We have, or unless there is another, because we have time for just one more.
so I have to modify it.
That's okay. Just it's a general idea at the moment.
It was a good one. I like it.
So, ma'am, I thought about consumers' preference as well. So I thought, so my title is the Reader's Dilemma, a discrete choice experiments on consumers' preference, whether they are choosing used books or e-books over the new books that are coming in the market. So my attributes would be, one is the edition of the book, whether it's a standard edition or the first edition or a signed copy by the author, and how people are choosing this kind of books over the other. And for ebooks, we'll give some climate nudge, by choosing this book you are saving 2 trees. This is one kind of climate nudge. And so I was thinking on that line. I've forgotten about the other attributes. I have to see.
It's different, and
Mm-hmm. I like it.
Kind of
my first reaction when I saw it is that it is an interesting topic, because it is not obvious to me what is the environmental cost of the e-book.
Yes.
So it's obvious that when you have a paper book, it's 2 trees, but I don't know about the e-book.
but I'm also thinking data storage takes so much.
Data storage, aluminum, lithium battery.
Sir was suggesting was something like in terms of resources. When we are using ebook, how much we are using lithium or kind of or such kind of things. And one of my attributes is also price, which looks at the economic side of choosing the book. And I have leveled it like the discount, 30% off from the MRP or 40% off. I have documented it in this way. And the other thing is the condition of the book, whether it's used and fair or brand new or just new. So I've done this in this way.
Space aspect also matters, right? Like those who prefer e-bills because they can carry wherever they want. Otherwise, you have to think for.
Yes, I was even thinking that we could add the thing whether it's instantly deliverable, like ebook, we can get it instantly, but not the new book. We have to go to a bookshop to purchase that. I was thinking on that line too, about ease of obtaining the book.
You can also add about the screen time, because these days
Yeah.
we have
So that would be the trade-off.
Switching back to reading books because there is a lot of screen time.
Yes, yes.
Difficult choice.
Yeah, that would be the trade-off part.
Yeah. screen time.
So, any other ideas? Somebody just wants to throw in ideas, even if it's not a full-fledged project. Or
I had just a slight question, and this has to do with more my PhD thesis topic, not so much here, but I was just thinking, like, just trying to formulate that, and I was thinking about like consultancies themselves and the way that they come up with solutions. For example, that's something that's a huge part of. So I work on transportation itself, as in I'm trying to look at it, India-Japan cooperation when it comes to transport systems themselves. So I was thinking, all these solutions, they come from consultancies. So for players like that, where you aren't really looking at people, you're looking at governments and agencies, and maybe I don't know, more of what suitability and that sort of studies. So how does DCE fit into something like that? Like what are the attributes there, and like can you really attach something to it? Can you say that, oh, is it right, is it wrong? Like as a PhD scholar that is working in social sciences, I could bring it down to, are people, how do people like it, and how do these private players look at it? So do you think that's something that is a possibility in that sense?
Yes, you could do something similar to what we did in the paper with in line titling, where you find someone that is working in the private sector and say, assume that you are going to provide an opinion, an expert opinion on the following scenario. What will you recommend? And that actually reminds me, there is another part of my research that goes into expert elicitation. So to me, it looks more like you want to consult the opinion on an expert and what that expert will recommend to do, and which scenario you will present it in the form of a discrete choice experiment, but you are asking an opinion as an expert.
There won't be so many respondents then, like if you have 500 in this, that's a very reliable number to go by, but in a study like this it would be much lesser than that.
Actually, the cool thing with expert elicitation is that it can be done with 10 experts. Right. So we can talk about that, because actually that is another thing we could discuss, but yeah, it is possible to do it with 10 depending on the specific question. I can show you some literature. Perfect.
Okay, so if there are no more, then we can close today's session, and then we will meet tomorrow. Thank you. Yeah, tomorrow is another exciting day. You get to present your ideas, you get to collect certificates, and you get to give us feedback. Feedback also.